All right. Let's do a pre-audio check. Go YouTube. Yes, go YouTube. Hey, Misha. Welcome. Different this time, right? Uh, so, yeah, I hope people can hear me. We tested everything yesterday, so everything should be fine. So we'll start at 2. I really hope people can hear me. Misha, give me some feedback, man, if you can hear me. I hope my moderator's here as well. Um, then can really start. But I really hope people can hear me and that nothing went wrong with the audio. Okay, perfect. Everything's fine. Can hear you perfect. Yeah, yeah. It's always difficult, right? Because I can't put on my own audio because then it starts like singing around. Because then you get myself with 30-second delays every time. But perfect. So nice. It's good that everything works. We still have like 7 minutes before we really start. So if anyone has any questions or something like that, just throw them in chat, and I will just continue sitting here, drinking my coffee, waiting for 2, so that everyone can join and that we can just have a nice stream. That that will be fun. Like I'm really excited about it. I talked to one of the students yesterday who had an issue with being not able to chat via YouTube. If that's the case, I actually sent around an email this morning with a Zoom link for all of the students. So if you have any issues with chatting on YouTube or you just don't want to make a Google account, because you can watch YouTube without having a Google account, of course, I'm not forcing you to make a Google account, but then of course if you have any questions, you have to go to the Zoom thing. Um, a little bit of a warning: uh, don't unmute yourself in the Zoom thing because that might actually be picked up by OBS, so that might then end up on the YouTube stream. But I don't think it will. I fiddled around with the settings, but I couldn't test it. So anyway, 5 more minutes, people. In theory, we could actually switch to the lecture layout. That's kind of the same thing as the other one. So then you guys can just see me instead of listening to me. But I don't know. It's always difficult just talking to yourself for like 5 minutes in an empty office. All right, so we have someone who entered the Zoom. Hello, moderator. Thank you for being here as well. So, 5 people already. I'm expecting 32 students to show up. We had 32 people who signed up for the course. Um, yeah, so let me type a message quickly. Uh, we don't have sound here. Let me send it to everyone in the meeting. Just for questions via chat. That's a nice amount. Yeah, yeah, I'm really, really happy with 32 people signing up. It's been great, right? In the like 8 years that I've been doing the course, we grew from having like 6 to 10 attendance in like the first year, kind of steadily. And I wanted to ask if I can still join the course since I am not registered yet. Um, sure, just send me an email, Jessica. Then I will just put you on the list of participants. Um, so that's perfectly possible. So that means that we have 33 students. So we're growing while we're not even started yet. So But yeah, I'm really happy that over the years, like the course has grown into what it is now. I think currently we have people from more or less all over the Humboldt University. And we started off with just because officially the course belongs to the Process- und Qualitätsmanagement Master, right? Which is part of the Albrecht Daniel Ter Institute. But it kind of grew. So I think we have a lot of PhD students this time. We have other people joining from all over the world, I think, because of the fact that it's on YouTube, which is good, right? Like I like people. Like I think education should be for everyone. And that just like if I teach the course and there's 3 students in the course, then only 3 people get to benefit from listening to me. But if there's 33 people who registered and there's like 50 people that just follow it on YouTube, then that just expands the number of people that get to learn R. And I think it's a very important skill. Like programming is one of these things that it will help you in the rest of your career, whatever you're doing. So let me quickly look at the list of registered students because we have a bunch of people that are not even from our faculty. So there should be a lot of fish people, a lot of PhD students. I think we have 1 or 2 Nebenhörers, even from outside of the Humboldt University. There's someone from physics, which is interesting. Um, so yeah, of course, most of the examples and assignments will use biological questions because, of course, we're from a biological master. So I'm really, really excited about that, and I'm really excited that so many people are following it. So I'm really happy about that. So let's just switch to the lecture layout so that you guys can see me as well. Let's see if that goes okay. Perfect, perfect, perfect. So I hope the light is not too bad. Yesterday when we did the test stream, like half of my face was kind of blocked out by shadow. So I hope it's better now. Fish people say Ayo, yeah. That's actually quite nice. I don't know why, but I do like the fish people. They at a certain point started joining the course, and we also had them in the course for the bioinformatics course, which you can see from last year and the year before. That's on YouTube. So yeah, I drew a fish yesterday. I'm horrible at drawing fish, so don't ask me to draw too many too many fish. Horticultural sciences. Yeah, yeah. Horticulture is, of course, it's the same as the fish people. Like you're more than welcome here. Like it doesn't matter, right? Like in the end, programming is for everyone, and if you enjoy it, then we're just going to make it fun and teach you guys how to do it. All right, it's 2. So I think we can more or less officially start. I will admit 1 more person into the Zoom meeting room so that they can also chat in there. The pufferfish, yeah, yeah, you can see me drawing the pufferfish on the YouTube, and that's really, really bad. Like that just went off the rails horribly, 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 horribly. It was a great, well, it was a fish. People could make out that it was a fish. So for the people that didn't see the test stream, check it out. It's very fun to do. All right, so let's start, right? So welcome, welcome everyone. I'm so happy that you guys are all here, and I hope that we can have a really, really good our programming course this year. And it's the summer semester course. The course will run from now until July 21st, I think. So July 21st, I think, is not going to be the last lecture, it's going to be the exam. And we will get into that. I made a couple of slides about the course overview and then we do an introduction. So what will we do today? So for today, general course announcements, because there's a lot of different course announcements to do. I wanted to show you guys what you will be able to do after you follow the whole course, right? Because you guys are here and I don't want you guys to go home and don't know what you will learn. And then we will start with my introduction to R. I changed it up a little bit from last year. It's not that different from last year, so it's a little bit similar. But I changed some images. I added a couple of slides. So I hope that it will be different enough so that you guys will enjoy it. So and of course, I will talk about the assignments because practicing is really, really important. Like I was talking to a student yesterday, and I described programming to him, or at least my idea of programming is this, that it's like playing a violin, right? So everyone can pick up a violin and can do this and can move his hands. But in the end, if you want to become a concert violinist, you just have to put in the practice hours. And the same thing holds for R. So when you want to learn R, you just have to put in the hours. You can listen to like 100 streams, you can listen or you can read multiple books, but in the end, the only way that you're going to learn how to program R is by just doing it, sitting behind a computer, failing, right? Because at first you will get errors, you will get warnings, you will bash your head against the screen, and that's okay. That's what I'm here for. So, a tip in advance, if you get stuck with the assignments, which you will, because some of them are really hard, I know this from last year, um, just send me an email, right? And the only thing that I require that is that you show me that you tried. So if you say, well, I tried this, it didn't work, I tried this, it didn't work, then yeah, I'm fine with that. Then I'm more than willing to help you. And even if you're not an official, like, student of the course, right? If you're just a random YouTube person that happened to enter the stream, then I'm more than willing to help you as well, because, like, I think that's my job as an educator. Actually, one of my colleagues um, came up with a new term that said like, no, you're not really a lecturer, you're more of a lecturencer, because I took my like influencer circle thing to have a little bit better light. So I like that term. It's a good term. All right, so next slide. So like I said, like the lecture slides and the assignments will be made available on Moodle. So if you're a student, you can just go to Moodle, everything's there. There's also 3 books on there. So if you like learning from a book, then there's 3 different books that were available during the pandemic for free, that you can download there, and then you can just read the books. So then that's more or less kind of an additional way. I don't know if I'm allowed to distribute them on my website, but if you want to get one of the books and you're interested, and you're not a student, so you don't have access to Moodle, then just send me an email and I can privately share you the PDFs. Please attend the lectures on YouTube, ask questions. The best thing would be is to just make as much noise as you can. So even if you just have like other things, you can always put them in chat. That's perfectly fine. That's one of the things that YouTube's really like, because the more kind of interaction there is in chat on YouTube, the better it is for the visibility of the stream. So that's just something from my side, which I just want to give you guys. That don't be quiet, don't hold back, ask questions. So like I said, the lectures are supported by practical exercises. Spend some time on them. If you get stuck, send me an email. And don't be afraid, because I sometimes have the feeling that people get stuck for hours on end and are afraid to ask for help. Don't be afraid to ask for help. I know that when you have no programming experience or only little programming experience, then you will get stuck on the assignments, which is perfectly fine. So for the students, I actually want to offer you guys an in-person meeting before the lecture. So during the first break, I will walk up. I will see if the lecture room that I have in my mind is available, so that we can meet there next week before I do the stream. So that would mean that the stream would be from 4 to 6, and then the in-person like lectures or the in-person assignments would be in front. But I'm not too sure about that, because I got a new PDF from the university with all of the rules that I have to adhere to when I want to do lectures in person. It's not too much, but I have to make sure that all of you guys are vaccinated and wearing masks and all of that thing. So it's a big hassle, but I'm more than willing to do that because I do believe that doing the assignments together is good, because then you can learn from other students. Students who are a little bit more advanced can help the students who are a little bit less advanced. So then everyone benefits from that. The exam date at this point in time, because people always ask me about the exam, it is unknown, but it's probably going to be the 21st of July, because that's kind of my aim. And I'm not sure if it will be online or in person. That depends on the Prüfungsbüro. And the problem with the Prüfungsbüro is that they only tell me, well, only a couple of weeks before the exam. And 3 shots here, let's do it. Yeah, I'm excited. Good, so that's the general course announcements, and then I have some questions for you guys. So first question for people in chat, or people in the Zoom thing. Why did you decide to follow the course, and how did you hear of the course to start off with? Like every time that I search for my own name in Agnes, I'm actually surprised that I can find my own course. And the idea is, like, of course, that this course is for you guys. So I'm just curious, like, how did people from physics actually end up finding our course, which is listed under the Albrecht Daniel Ter Institute, which is biology. So I know there's a little delay, so I will just wait a little bit for answers. And of course, you can answer the other questions as well, right? You all can read, so any prior statistic courses or any other experience that you have with programming would be good that I know that, especially when we start doing the assignments. Because if there's 1 or 2 or 3 people that do the assignments and they have a lot of programming experience in Java or in C++, then that would be perfect, right? Because that would be good, because then I don't have to help everyone, because I'm only one person. We have, like I said, 32, 33 people who signed up, so that would be nice. All right, first answer. I searched in Agnes for statistic and found the course. Interesting. Interesting. I never find anything with Agnes. Every time that I try to search for something, the only way that I know how to find my own course is just by filling in my name in the lecturer field, and then it comes up. Fellow students told me about it, and I thought it sounds really interesting and like something important to learn. I agree. I agree a lot. Biology is, well, it's not a dying field, right? But like as a wet lab biologist, you will be forced in the future more and more and more to do programming, because currently we have so many techniques that generate so much data, that without any programming experience you won't be able to handle your own data. And I think that's a shame, because in the end, if you are doing an experiment and you're spending time in a lab, like collecting samples and extracting DNA and doing sequencing or whatever you're doing, being able to analyze your own data just makes it more fun, right? I see people in the lab here that are really good in doing lab work, but in the end, they get a hard drive back with their data, because the analysis is done by some company, and then they have to come to me, and I get to do the fun part. I get to look into their data, see if there's any signal or any other really nifty, nice biological effects, and that's what I like, right? Like extracting this from data sets. So does anyone have a very specific objective in what they want to learn? Because the course is structured in such a way that there are like 11 to 12 very basic lectures where I will teach you guys how to load in your data, how to do some basic statistics. But there's always 2 free lecture slots, which I try to reserve for people that are working on either a very specific data set, or people who have very specific requirements for their master. Searched all over for training for social scientists. I'm a sociologist doing, but I need to upgrade my quantitative skills. Okay, that's very good. Found it via recommendation, no experience, only with data preparation. Perfect. All right, so that's good. That's good. But yeah, like I said, there will be two additional courses. Um, Let me read chat. As mentioned by the professor before, the R language is used to process the data more scientifically, so I want to learn R. Yeah, including better statistical and even graphing. Yeah, yeah, there will be a lot of like focus on visually exploring your data. I am a very visual person myself. If I see an ANOVA table, I can kind of get an idea of what's going on, but when I physically see the data by using box plots or scatter plots, I can kind of understand much more what's going on. So it's good that actually people are recommending the course from last year. That means that the news is spreading, right? That we have a fun R course. Yeah, so if anyone has a data set that you are currently working on or going to work on and think it would be good that this guy has a look at it, then we can make a lecture out of it. So if you go to the course from last year on YouTube, then you see that there are three lectures, or there's one lecture which is split into three parts, and that is called the fishy data lecture. And there we took some data from the Baggersee project, which was collected by Professor Arlinghaus. And I just went through the data and made a presentation about it, right? So like, how would I analyze your data? So if you have these kinds of things, then do mention them. The information was shared. I find it interesting and excited to learn about it. I didn't have any experience. My main objective is to gain the skills for data analysis. Well, then you're at the right place because that's what we're going to do. Perfect. Okay. So yeah, if you have any data sets, just drop me an email, throw it in the comments, throw it in the chat, saying that no, I'm working on this beautiful data set. Like one year we had someone from um, I hope you can read this. Yes, I can read this. I'm looking both at the chat on YouTube and at the Zoom thing. That's why we have the Zoom thing. I have a little experience with R, and my main aim at this course is to learn the time series analysis, which I need for my dissertation. Perfect. I love time series analysis. I actually have a paper under no, it wasn't under review because it was directly rejected, so I have to resubmit it to another journal, which is about time series analysis. But I love time series analysis as well because it's nice and visual. I like looking at things like growth curves or other things over time, and I think this time dimension to data is really interesting. So sure, I will put it on my to-do list, and time series analysis, we have it in there already a little bit when we talk about like the generalized linear models and how to use generalized linear models to analyze repeated measurements. So repeated measurements can also be repeated over time, right? Because time series data is just measuring the same individual over different time spans. So cool. All right, then I have some ideas on what to do for the two lectures that are at the end. If you have a data set, like I said, send me an email. I'm more than willing to look at it and make a nice presentation based on your data. All right, so I told you guys that I would want to tell you guys what you would be able to do. So, and this is not going to be after these first 3 hours, of course, right? This is for the whole course. So what we will be able to do is to format your data for R, which is something that I noticed that especially with biologists is hard. Um, all right, message in chat here to learn data analysis too. I'm garbage at statistics and the master thesis is coming. Oh yeah, that's one of the reasons I see a lot that people follow it. That they have some kind of data already collected for their master, but when they have to do the thesis, they have to do the statistical analysis and put p-values on everything, which in a way I don't think is that important. Like I think that if the effect is big enough, right, and you can see it clearly in the data, or you can see it clearly when you plot it in a box plot, then the p-value itself is relatively meaningless because in the end, if it is really significant, it's significant, and then it doesn't matter if it's like 1 times 10 to the minus 3 or if it's 1 times 10 to the minus 16, right? Significant is significant. So the exact value of the test is not that important in many cases, especially when the effect is big. All right, so back to the slide. What will you be able to do? Format your data, which is generally a big issue. I see a lot of people that collect their data in Excel and then use like different colors in Excel to denote what went wrong or what went right. And of course, like for a computer, this cannot be understood, right? A computer needs a very specific structure of data so that it can load it in, that it can reason about the data. And I see it in is prior knowledge? No, no. All knowledge that you will need to pass the exam and follow the course is going to be presented. That's why generally the lectures are relatively long. I think in the last semester, or not the last semester, but the last time we did the R course, it's like 48 hours in total of me talking. And you guys asking questions, of course. So no, there's no prior knowledge required. So when I talk about a t-test, I will show you guys what a t-test is. When we talk about linear models, I will tell you what a linear model is, what the assumptions are, and these kinds of things. So load your data in R, format your data. So that's kind of the first 3 lectures. So you will spend around 6 to 9 hours of lectures on just the basic understanding of R, how to get your data in. And we will discuss some very, very advanced topics at that point already, right? Like reading in binary data, which during my whole career, like 14 years of working in bioinformatics, I only used a couple of times. So we will go very deep into kind of formatting your data, loading in your data, and some of these things you won't use for the next 10 years, even if you're working as a bioinformatician. But I just want you guys to know how to do it and know that it exists. So in case it comes up in like 5 years when you're working in a lab, that you know, okay, this is there. I'm taking the lecture again and I'm just looking it up, like how did this guy do it like 5 years ago. So use statistics to answer your questions. This is of course very important. I will teach you how to formulate questions and then formulate these questions into programming code which the computer can then answer, because asking the right question is very important. And of course interpreting these results. Last year, I think I went a little bit short on the custom plots. I think people like custom plots a lot. I noticed this also during the bioinformatics lecture when we did the volcano plots. So people really love having code to make custom plots. And I think that last year I skimmed out a little bit on that. So I think we will extend the plotting lecture to make sure that you guys can use basic R to make really beautiful looking plots. It will take a lot of time, right? If you make a very good plot, which is suitable for publication, it generally takes you in the order of like 3 to 5 hours. Just tweaking everything, making sure that the fonts are correct, that the axes have the things that they need to be, that everything is the right color, and that there's enough like difference between colors. So I think last year I skimped out a little bit, so I'm going to try this year to add much more to the plot lecture, which is lecture 5, I think. And then in the end, I want you guys to be able to create your own analysis, right? I have a Excel file. How do I load everything in? How do I write functions to analyze my data? How do I do statistics? How do I create a plot in the end? And then lecture number 9 or something is going to be making an R package, right? So because in the end, if you wrote some really genius code, then of course you want to share your code with the world. And you want other people to be able to make the same beautiful plots that you made. So publish your work as an R package for others to use. That is, I think, more or less the end goal. And if we get there and everyone is able to write a couple of basic functions, do a little bit of statistics, load and save their data, and make a package out of these things, then I would be very happy, because then we reached my goal. Because from that point on, it is just practice. It's just looking things up that you need, because everything, or there's like thousands of packages available for R, for machine learning and all of these things. So, but that's the end goal, that you can write your own functions, make your own plots, and then publish your work so that other people can use it. All right, so analyze your own data. So what you will be able to do is make plots like this, right, where we look at the guinea pig's tooth growth, giving them different types of feed supplements. So there's guinea pigs that are drinking ascorbic acid, and some of them are drinking orange juice, and then some person measured their dose. So this is one of the basic data sets that's in R, and I would like you guys to be able to visualize it, right? And use nice colors, and have like legends in there so that everyone understands what's going on. And still, this plot is not perfect, right? You can't publish this plot in a journal. For example, if we look at the y-axis, you see there's tooth length, and there's the like tooth lengths in millimeters or meters or centimeters. I don't know, right? So there's still some little things that need to be improved in this plot, and one of these things here is, for example, this double axis on the y or on the x-axis, 0.5, 0.5. So here there's still something that can be improved. You will be able to make other kinds of plots, right? So these are things like heat maps, or in R they're called image plot, and these can be combined with things like these lines which you see in geography maps, right? So these kinds of things. But in the end, I want you to create your own, right? So this is one of the old images that was in the previous presentation, and I didn't like it. It was just a very basic plot. But because the way that I'm using a black background, I want everything to be white, right? So I want to have a white axis, white labels, white legends, and the same thing holds for these kinds of plots, right? So in the end, I want you guys to be able to take your data, visualize it, and learn something from that data. And of course, the most important thing is making your own, because like just taking standard stuff off the shelf doesn't make you a programmer. It just means that you can use other people's code. But in the end, what I want you guys to do is to be able to write your own code, make your own plots, make them look fancy. All right, so that's it for more or less the introduction, the course overview. So if there's any question, just throw it in chat or throw it in Moodle. If you have very specific questions, then I'm more than willing to answer those. But if they're not, then we are going to start with the introduction to R. So this is a very basic presentation that I always give. I've been giving this presentation, I think, since I was like 20 years old. I used to do this at King's College in London, and I would already show. So some of these slides they date back to like 2008 or something when I first did the King's College lectures. But it just grew into a full presentation, and I do think that it's a nice thing to show you guys. So what will I be talking about during the coming 30-35 minutes? Well, mostly about the history, and then we will take a break. Then we will talk about the look and feel of R, although I might add that to the history depending on how quick I go through the history. We will be talking about using R as a calculator, so that at least we discuss some of the basic stuff. Let me actually delete that. I will say remove. Good. I have to do some moderating once in a while, and actually let me just hide this user altogether. Oh, I don't have the right tools yet. I'll put the user in timeout as well. I'm still learning YouTube, so bear with me when stuff like that happens. All right, so look and feel of R, how to use R as a calculator so that we start doing the basic things like type in 5 plus 5 and it will give you 10 and these kinds of things. But we'll go just not in depth, but we will go broad, right? How to use complex numbers, how to use other things. We will be talking a lot about the R-type system. And this will be a recurring theme throughout the lectures because it's one of these things which is really hard for people that are beginning with programming. Because different types have different properties. For example, if you have a character, you can't do computation with it, right? You can't say, I have the word school and now do +1 on it. Right, so there's different types in R, and because R is a language also for statistical analysis, there's also different data types which don't occur in other programming languages, right? Because, for example, something which is a categorical variable is not something that is easily translated to a language like Java or C++. So sometimes there's people that have experience in other programming languages and they are totally confused by the different types that R has. So we will be talking a lot about that, and also how to index things like a vector and a matrix, which is really hard and will take some time to get used to and to kind of get the mindset on how these things work in R. We will talk a little bit about variables, but that is already going to be part of the next lecture. So really in detail, in depth about variables that we will do in next week. And I wanted to show you guys how I want you guys to answer the assignments. So answering the assignments means writing little scripts. So that's something that we will go through. And I have some specific requirements on scripts because I think it just helps when people work diligently. I always say programming is kind of like working in a lab. You have to be very careful. You have to look at like every bracket, every dot, every comma, which is the same in a lab, right? If you just don't read the tube correctly and just throw the chemicals on your sample, then you run a big risk of destroying your sample. Fortunately, in computer science or in R, it's really hard to destroy your computer. So feel free to type anything into the R window. It's really hard to crash the whole computer or do other crazy stuff, which in a lab is relatively easy, right? Mix the wrong chemicals and you have an explosion. Fortunately, programming is not like that. Why do I want to start off with history? I think history is very important. I think many people know the beginning of the quote, but they never saw the whole quote. So why do we do history in our course? Well, if I wouldn't be a bioinformatician, I would probably be a historian. I really love history, have loved history since high school, and I think it is very important. So I will just read the quote to you. It's the full quote done by John of Salisbury, and like I need to have some kind of knowledge questions as well that I can ask during the exam. So if I give you the quote and I ask who did the quote, then of course you have to tell me that's John of Salisbury. And there will be multiple quotes throughout all of the lectures. So it's just so that not all questions have to be about like programming and writing programs, but that we have some kind of basic introductory questions as well. So let me read the quote. We are like dwarfs on the shoulders of giants, so that we can see more than they and things at a greater distance. We are carried high and raised up by their giant size. And this is really true, especially in computer science. Like the computer that you're currently using to watch this thing on is the end result of almost 2,500 years of development, which involves hundreds, if not thousands, if not hundreds of thousands of people, and all little incremental steps. Every new generation of computer is a little bit better than the one before, and I think that kind of signifies this quote for me. And the same thing is for programming and programming languages. Like C as a programming language is kind of the most important programming language in the world, and C itself became 50 yesterday. But there's still new versions of C coming out, and it's still an evolving language. And language itself and the expressiveness of language is really important. So by knowing what was done in the past, what we are looking at in the near future, I think you can get a more broader overview of what programming is, and it just helps you to see more than the people before you. So we start off originally when I gave this course in King's College, I would start off in a kind of Sheldon Cooper way, like 2,400 years before Christ, in Babylon on a quiet evening night with stars falling down, there was someone whom we don't know the name of who developed the abacus. And the abacus is the first kind of tool that people used to do computation, right? So very basic things like adding things up, multiplying things, subtracting things. So it's kind of an external memory so that you don't have to keep everything in your mind. So I don't know how many people are here that actually used an abacus in elementary school, but my elementary school still taught us how to use the abacus, same like the geometric triangle, and the other like things that you use when you navigate a ship. But the abacus itself is kind of the starting point of modern day computers. It's an external memory so that you don't have to keep everything in your mind, and it can help you do computation on larger numbers so that you don't have to write it down or do other things. Then the next big invention came in, you did 40 years ago. Yeah, no, I think that the abacus is something that people should learn. It's an interesting tool, and it shows you how people in antiquity actually did computation and calculated prices, right? Because people have been bartering and trading and trying to navigate the seas for literally tens of thousands of years. And this is really one of these fundamental things. So 1100 BC, there's a big new invention which came from China, and that is using differential gears. So differential gears are the things that make you, or that enable you to do, instead of just multiplication, dividing, and plus and minus, right? It allows you to do integrals. So you can integrate over a range of things. So hey, if you think about functions, then you have like hey, you have a line which goes on an xy plane, and then at each point of the line you can calculate, for example, the directional coefficient, right? So this directional coefficient can be calculated using gears, and these differential gears stayed with us until kind of the beginning of well, almost until the end of the Second World War. A lot of tools that have been developed use differential gears. But the Chinese used it to build one of these things here, which is called a south-pointing chariot. So it is a little car that for children that you can play with, but the little man on top always points to the same direction. So it always points south, or it always points north, depending on where you pointed originally. And this is done by a mechanism which is inside of the little car, which uses gears. So when the wheels turn, it calculates the amount of revolutions on the one gear, on the other gear, and then based on that, the little man on top is moved into a certain direction. So the next big improvement is then the Chinese abacus. So that is a more advanced abacus than you see here. And that is an abacus which allows you to do plus, minus, multiplication, divide, but also to do integration. So to calculate x to the power of 2, or the square root of something. So a much more advanced abacus. I think that's the one that you usually see in classrooms, the Chinese version. And I think that it has changed since 200 BC until like 1980 or 1990. And then no one used it anymore because we use calculators. So in 120 BC, which is still in the middle of the Roman age, right? There is one of these more or less magical or mystical objects from antiquity, which is called the Ankythera mechanism. So that was developed in Greece, in Corinth, and you see a graphical design here. So this uses these differential gears. This uses a gear system to, most likely, we don't know exactly what it was used for, but keep track of all of these celestial bodies in our solar system, right? Because most of the computation that we do today has its basis in navigation. So if you are on a ship, you know the time of day, you know where the stars are, can you figure out where you are on the planet? That was the main difficulty for almost 2,500 years. Nowadays we use GPS, which is really easy, but for almost all of human history, this was the biggest challenge, to be on a ship in the middle of the water or on the water in the dark and not crash into the shore. That's kind of the trick, right? Because then you die, so you don't want to do that. So there have been a lot of tools developed, and the Ankythera mechanism is one of these like things that is almost like a modern computer, right? It's really good at tracking the sun and the moon and the movements and figuring out where you are on the planet. So an updated version of this is called the astrolabe. The astrolabes have been used until like 1940s, 1950s. So people would use a sextant to measure the inclination of the sun relative to the horizon. You would measure the North Star, or if you're in the southern hemisphere, you would use the Southern Cross. And then based on this, you would calculate, together with the time of day, you can calculate where you are on the planet. So it will give you an kind of an XY coordinate of where you are. And then actually nothing really happened for around 700 years. So in around 800, we have the development of cryptography, which is one of these major steps again in computation. Before that, people used very simple ciphers to encrypt their messages, right? You can imagine that if you are leading an army and you are a general and you want to send messages to your troops, then of course you're not going to write down "we attack at 7 p.m. or 7 a.m. in the morning," right? Because then any enemy finding this message will know your plans. So Alkindus is more or less accredited to the main inventor of cryptography, and he also developed frequency analysis. So he developed a formal system of cracking encryption. And because of the fact that he developed a system to crack encryption, he also developed a better system of encryption. So this is where kind of the NSA, FBI, FSB arms race starts, right? So where better and better encryption schemes get developed to hide the messages from the enemy, and to be able to say attack at dawn without anyone else knowing except for the people that you want it to know. And this is, of course, in the golden age of the Arabic world. And then 400 years later, we have the development of the first castle clock. So this is a mechanical clock which keeps track of the time, but it also keeps track of the sun and the moon position. So it is one of these things from antiquity which I think still exist. I think if you go to Mosul in Iraq, you can still see this ancient castle clock. It's like the one in there's also one in one of these European cities. I would say Switzerland. My moderator would know. We actually saw it. It's one of these like things from the dark Middle Ages where there's this big fancy clock, which you can see in Europe. But the oldest one is actually located in Mosul in Iraq. And then, of course, in 1673, which is the Enlightenment period, we had a big step forward again, and this big step forward is called the Leibniz wheel. So this was developed in Germany by Gottfried Wilhelm Leibniz, and he actually made the first, more or less, pocket calculator. It's not a pocket calculator. The thing was like this size, so you couldn't put it in your pocket. But it is kind of the predecessor of all of the calculators that we have. You missed the topic, I'm afraid. The castle clock, or the fancy clock within Europe, we went there on holiday with your parents. Just as a thing. Which city is it in? I would say Vienna or something, but it's not Vienna. I think it's something else, but it doesn't really matter. But there's a very old one in Europe as well. I think that's like 1500, so that's 200 years later. Prague, that's it. It's the fancy clock in Prague. People go there and it's like massively expensive. Anyway, I will read you guys the quote from Leibniz. I think it is, if you are a programmer, then you identify with this quote directly. So, it is beneath the dignity of excellent men to waste their time in calculation when any peasant could do the work just as accurately with the aid of a machine. Right? So this is kind of the basics of, because before that, smart people would spend hours and hours and hours doing long divisions on pieces of paper, doing computation on pieces of paper, things that we now just punch into a calculator. Before that were done by hand. So people would do long division, and this would literally take hours, if not years, for some big computations, right? There's this famous example of people calculating pi by using this circumference method, and this would take literally like years of your life to compute a new additional digit of pi, right? And now, of course, we have computers, so we can calculate pi until like the thousandth digit accurately. But in that time, you could spend more or less your whole life as a PhD student, so like a 4-year PhD student, just doing computations to find one additional digit of pi. And it's just an excellent quote. I love the fact that um, it's so ancient, and it shows that how people thought, right? Like there are excellent men and there are peasants. I kind of like that. I also love his wig. He has a good wig. That's a perfect thing. All right, so then we start with the real computer history, right? So with with Leibniz, we had the Leibniz wheel, which is kind of the predecessor of the pocket calculator. So we have Charles Babbage, and he is more or less in the history of computers. He is the inventor of the modern day computer. His computer is called the analytical engine, and it was not built during his lifetime. So it is a kind of general purpose computer which can be used to compute anything that you want. But at that time, the steel and the ways that they would make steel and how they could were not good enough to make the little cog wheels that were needed for his computer. So this is not a digital computer, it is an analog computer using cog wheels. And then you could set the input to the using the cog wheels, and then you would turn like a big thing and it would do the computation, and then the output would come out. But they actually built one in the UK a couple of years ago, 10, 20 years ago, I think. And it turns out that his machine really worked. So the analytical engine is a computer, the first general purpose computer that only existed in the mind of Charles Babbage, not just in his mind, but also in the publications that he wrote. At the same time, we have Ada Lovelace. Ada Lovelace and Charles Babbage had a strange relationship, but what she is known for is she is more or less accredited to be the first real computer programmer. So she wrote algorithms, computer programs that would run on Charles Babbage, his analytical engine. So she would write programs for a machine that didn't even exist. And she didn't get to be too old, but in memoriam of her, there is a language called Ada, which is one of these famous programming languages. So she is the first computer programmer. She is the inventor of recursion, which we will come back to in like lecture 6 or something. But she wrote in her letters with Charles Babbage, they wrote, or she wrote, computer programs for his non-existing analytical engine, which they would hope would be built one day, which actually we did. Using modern steel, modern CNC machines, you can make cogwheels and gears very tiny, and you can build this analytical engine, and it turns out that it really, really works. Then in 1912 to 1945, we have the life of Alan M. Turing. Alan M. Turing is one of these people who is more or less the godfather of computation, so not the inventor of the computer, but he is the one that cracked the German Enigma machine in the Second World War. But in computer science, he's not so much known for his ability to crack the Enigma machine, but he is known for developing the Turing machine. So the Turing machine is a hypothetical machine that allows you to reason about what you can compute and what you cannot compute. So I added an extra slide because I think this Turing machine is really, really interesting. So the Turing machine, again, like the analytical engine, is an abstract machine. It is a machine that does not exist in reality, because it is a machine which has symbols, so zeros and ones, on a tape, on a strip of tape. And for the whole computational complexity computations to work, this tape needs to be infinitely long. And of course, you cannot produce an infinitely long tape. But besides this tape, where you have a head which can read and which can write numbers on the tape, there is also a table of rules for manipulation. So here you see a very basic Turing machine being built in Lego, and here you see one which is more or less built using a more or less digital computer memory. But what a Turing machine does, it has a table of rules. So the rule says if you read a 1, move to the left, right? And it has internal states. So based on what it did previously, it can do other things, right? So if you read or if you moved left and you read a 1, then write a 2. So it has this table of instructions, and with this table of instructions and this infinitely long band of numbers where you can write and read from, you can reason about what you can compute and what you cannot compute. And the nice thing is that any computer algorithm that exists today can be implemented by a Turing machine. So we often say a certain language is called Turing complete. That means that you can compute anything that you will be ever able to compute using this language. So something like HTML is not Turing complete, but something like R is Turing complete. And this is where the whole computational complexity theory comes from. So godfather of more or less computational complexity, he allows us to reason about what we can and what we cannot compute. All right, then we start with the real computers. So the first real computer was built and finished in May 1941. The first real computer in the world, and you heard it here, is the Z3. If you talk to an American, they will say, that's not true. The first real computer was built by Americans. But that's not true. The first real computer was built right here in Berlin by someone called Konrad Zuse. So Konrad Zuse built the Z3. He's an autodidact, so he taught himself everything and in the end became a professor. But he built this computer for the Germans, for the Nazis at that point in time. And this computer was used to study wing flutter. So wing flutter is the phenomena that when you fly an aircraft and you fly it very close to the speed of sound, then the wings start flapping because of the air resistance, right? The faster you fly, the more air kind of builds up on the wing. And when you reach the speed of sound, you also have this sound wave, so you get this kind of instability. And the wings start flapping, and if you go any faster, then at a certain point your wings will just fall off your airplane. So to study this phenomena, they built the Z3. And the Z3 is the first general purpose computer. It's not fully digital. There are some analog components still in there, but it is generally considered by most experts to be the first real computer in the world. The programming language which was used to program this computer, which is also invented by Konrad Zuse, is called Plancalcul. And in the year 2000, the FU in Berlin actually wrote a Plancalcul compiler. So it is nowadays a real computer language. For Zuse, it was more or less a toy language which he used to kind of reason about what his computer could do and how to program the computer. But the original Z3 was destroyed in 1943 by an Allied bombing run on Berlin. So you can actually find a Z1 replica in the German Museum of Technology, and there are other replicas across Germany because of the fact that this is really one of these main achievements, which people generally accredit to the Americans, but actually should be accredited to the Germans. So of course the Americans struck back, and the ENIAC is the first real computer that the Allies built in the Second World War, and it is called the Electronic Numerical Integrator and Computer. So that's also where kind of our term computer comes from. And it is the first real full electronic general purpose computer. It is Turing complete, which means that any algorithm that you could think of can be programmed on the machine. It was fully digital, so there are no analog components, and it was capable of being reprogrammed. Reprogramming at that point means that someone had to go physically to the machine, pull out a cable and plug it in somewhere else, right? When you think about people being on the phone and having these phone switchboards, this is kind of how this computer was programmed. So you would input the program by connecting certain parts of the switchboard, and this would have a certain meaning. But the computer is a full computer, so it supported looping, so you could do a for loop or a while loop. It supported branching, which means that you can do if statements, and it supports subroutines, which is what we now know as functions. And the purpose of this machine was to calculate ballistics tables. So of course, when the Second World War ended, the big issue was is that we had nuclear weapons, which we wanted to put on top of rockets. But when you launch a rocket, you kind of want to know where the rocket will land. So, and for this you need ballistic tables, which you can look up, like, okay, so I have my speed, I have my inclination, and these kinds of things was what the ENIAC was used for, to calculate if I launch my rocket, where will it drop down and what city will it hit. So ballistics tables was what they computed with it. Another very famous person is John von Neumann, and in 1945 John von Neumann came up with the von Neumann architecture. So nowadays all computers that we have in the world are von Neumann machines, which means that they are structured in a way like this. And every computer still is, right? So you have an input device, which for example can be a keyboard or a mouse or a drawing pad, and then you have the computer itself, and then the computer itself is connected to an output device. So the output device, be it a screen, be it a printer, be it something else, a robot arm for example. But within the computer you have two main components. One of them is the memory unit, which stores things in memory, and you have the central processing unit, which is nowadays called the CPU. And CPUs are divided into two parts. So you have any CPU in the world will have two different parts, and one of them is the control unit, which keeps track of what we are doing now, and then you have the arithmetic and logic unit, which does arithmetic, so plus, minus, divided, but also logic. So logic means Boolean logic, which means that if I say true and true, then that's true. It can be true and false, then it's false. True or false is of course true. So you have these like logic tables, and a computer can only work because of this, right? Doing plus, minus, multiplications is not good enough. You also need to be able to evaluate if a certain statement is evaluating to being true or if this statement is evaluating to being false. And John von Neumann kind of popularized this architecture, saying that no, you need these four individual parts to make a computer, and had this central processing unit. He's also the one that coined the term CPU, needs to be control unit and an arithmetic and a logic unit. So this is called nowadays an ALU. So it's a CPU, and every CPU has several ALU units which can do computation, and it has a control unit to kind of direct the flow of the memory into the different ALUs. So nowadays, I always love talking about this. I don't know much about it because I'm more or less a bioinformatician. I'm not a quantum physicist or anything, but I think that it is really interesting to see that since 1976 we started developing a new type of computers, completely different from the von Neumann machines. And this started with Roman Stanislav Ingarden, who developed quantum information theory. So the theory of how to use quantum superposition to do computation. Then David Deutsch in 1985 posed that you can actually build a universal quantum computer. So hey, you can take these qubits, and then using qubits you can build something which looks and resembles a computer like we know, but which doesn't use zeros and ones, but which uses like superposition, which means that a single byte can both be 0 and 1 at the same time, or more or less 255 different states between there. So very interesting theory, but we couldn't really do anything with it until 1991, when people figured out that you can actually use this quantum entanglement. So you can have two particles, you can entangle them together, and then you can use this to secure communication via undersea cables, right? If you are America talking with Europe, you don't want a Russian submarine to cut your cable and listen in on all of the communication that you do. So nowadays, if you think about fiber optic cables, then these are secured using quantum entanglement to provide secure communication. In 2011, the D-Wave 1 became available to the market, and the D-Wave 1 is the first real quantum computer. So it is a computer which is consisting of 128 qubits, and you can run quantum algorithms on these machines. In 2020, the D-Wave Advantage was launched, and the D-Wave Advantage is the newest generation of quantum computers. It's not a full quantum computer. It's not a universal quantum computer. It only does a certain part of quantum mechanics. But the D-Wave Advantage is one of these computers which is really interesting because it's like 5,000 qubits, which seems really small, right? Nowadays your computer it's a 64-bit computer, but you have like terabytes of them. Yeah, so it's a big CPU, big memory. This is a relatively small computer, but it outperforms any normal classical computer that there is on certain tasks. Not all tasks, just certain tasks. So how does this thing look? So the D-Wave 1, you see a picture here, it's just a big back box. And the CPU, so the central core where everything happens, looks like this. And this is a gold-plated little chip which is cooled to around 200 degrees below zero. And this chip can do quantum computation. You pay around $10 million for it. So that was in 2011. So in 2011, a computer like this would set you back $10 million. But this is very similar to the price of the original ENIAC. The original ENIAC was around $500,000 when it was built, which if you would bring this amount of money from the past into the future, that corresponds to around 6.1 million US dollars. So the D-Wave 1 is kind of the first computer of a new generation of computers. The D-Wave 1 was used in biological research to study lattice protein folding. So how do proteins fold? And you can use a classical computer to compute this, but then you have to go through a lot of iterations, and hey, you have to do a big for loop, and every time you have to adjust all of the atoms. But this computer doesn't need to do that. It gets the input protein sequence, and then because of the way that quantum computers works, it more or less instantaneously knows the minimal energy state of the protein. So lattice protein folding is what the D-Wave 1 was used for. Of course, nowadays we have the D-Wave Advantage. The D-Wave Advantage is used by many big corporations in the world. It's again, same box, just with different colors and Advantage written on it. And it's used by Menton AI to do protein design. So to design new proteins to help people in disease research or do protein docking. And it is also used by Volkswagen to schedule the paint shop. So Volkswagen creates a lot of cars, right? And these cars need to be painted. But people order different colors of cars. And you don't want to paint one car blue and then switch all of the equipment and then paint the next one red and then switch everything again and then make a blue one again. Right? So you need to schedule this in a way so that you do as many blue cars in a row as you can, and then you do as many red cars before switching to a different color. So this paint shop scheduling is actually done by a quantum computer nowadays. The same thing is for Save on Foods. They use this D-Wave Advantage to optimize their grocery delivery schedule. So this is one of these problems which originally, the traveling salesman problem or the grocery delivery problem, if you have an X number of stops that you need to make, right, or you know the physical position and the roads between how to get there, then a normal computer cannot give you the optimal route. It can give you a good route, but it cannot give you the perfect route. And a D-Wave Advantage or a quantum computer can be used to do these grocery optimizations much faster than a normal computer. It still won't give you the optimal route, but it will give you a very good route at a very good in a very limited amount of time. Amazon also uses D-Wave advantages, and this actually was a really great opportunity for people who are interested in quantum computing, because they used to offer free access for COVID-19 researchers, because of the protein folding that you can do with these machines, right? So when COVID first hit, people didn't know much about it. They know the genomic sequence, but they didn't know anything about the proteins, how they would fold, that the spike protein has different conformations and stuff. And that was the thing that you could actually apply for. So you could write an email to Amazon, and then you could get free access to one of these quantum computers to do optimization, protein optimization, and these kinds of things on COVID-19. I don't know if it's still free, but I think so. Will I need to remember everything about these computers in order to successfully use R? No. But you will for the exam, because the exam, of course, is going to have some questions which are more general, right? So I love people that do that won a Nobel Prize. So I tend to ask questions like, who is considered the first computer programmer? Just a couple of like warm-up questions before we get to the hard stuff. So so you don't have to. It's just to let you know where we are and where we are going, right? So all of the programming that you are learning today in R, in like 50 years probably won't exist anymore, because we would have switched away from classical computers to quantum computers, and that's a whole different way of programming. So, but you don't have to know all of it. Just get the general gist that we're in a process of, again, moving away from mechanical calculators to digital computers, and now we're in the process of moving away from digital computers to quantum computers. All right, the same history again, but now for programming languages. Because of course, there's a history of computation, but there's also a history of talking to these machines, right? And especially digital computers have a history of that you need to talk to them. So I don't know if anyone is like old like me and Misha, but when I was younger, when I would go to the hospital, I would get one of these little cards after entering the hospital with holes in there. And then this card would hold part of my information. So they would plug the card into the machine that they had, and then that would do all kinds of rattling. And then, thanks, man. Yeah, I'm sorry. Like, you're just as old as me, right? That, like, or just as young as me. That's how to say it. Don't want to offend you, but we're not squeaky young master students anymore, unfortunately. So that's just the way it is. But these punch cards, I'm 46. Okay, I'm just as old as you. Not 46 yet, but almost there. Like, I feel 46 on some days. But like low-level programming languages are punch cards, right? So physical cards with holes in there, which you plug into a machine, and then it goes in through this. It's like these little. It's like these music boxes, right? That you used to have. So the information is like the music in a music box. So it's the spool, and if it's a 0 or a 1, so having a hole is a 1, not having a hole is a 0. So to get away from that, people developed something called assembly. So assembly is the first language, which is an operand language, and this is a very, very low level language. So it's something that the CPU can directly understand. So you're directly talking to the CPU. But like I said, C yesterday was 50 years old. It's developed by Dennis Ritchie and Ken Thompson. It was developed between 1969 and 1973, so there's no real official, like, this is C date. But C is kind of the computer language that is ubiquitous. If you have a computer, then the operating system that you are using is using C at some point in booting up. And it doesn't matter what operating system you use, be it Android, be it Windows, be it Linux. And then, of course, there's a whole bunch of high-level programming languages. So what's the difference between a low-level and a high-level language? Is that a low-level language is you are talking directly to the CPU. But high-level languages have like an abstraction layer on top of that. So you are talking not directly to the CPU, you are describing what you want the computer to do. This is then fed to a compiler or an interpreter, and this compiler or interpreter is a program which translates your high-level language into computer instructions which the CPU, so this ALU unit, will execute. So you don't have to code, hey, you don't have to say, take this memory location and take it from random access memory, drag it to the CPU. But you have to be aware that this still plays a role. So if you're dealing with gigabytes and gigabytes of data, then sometimes using these high-level languages can cause your program to be really slow because it knows about the CPU, it knows about but it cannot optimize, for example, the throughput from the memory to the CPU. So some high-level languages, Blanco Cool is the oldest one, developed by Konrad Zuse. We have Autocode, which is developed by Guinea in the 1950s. We have Algol, which is still being used a lot, and that was developed in the late 50s. Lisp is one of these languages which is still used a lot today, just like C is, which was developed by John McCarthy, and it is the core language for artificial intelligence. So many of the artificial intelligence algorithms that we use nowadays are written in some form by Lisp. I always like to mention COBOL because people that want to earn a lot of money with programming are in the wrong course. R won't make you rich. Learn COBOL. COBOL was developed by Grace Hopper in 1959, and it runs more or less the aviation industry and the financial industry. So if you can program COBOL, you can earn a lot of money working for a bank. You will have a very shitty job because you're just maintaining code that has been written by other people like 10, 15 years ago, but that's where the money is. So making sure that the world financial system, the fact that they call the language Lisp. Yeah, well, I think it's an abbreviation, right? Most of these things are. But Lisp is an interesting term indeed. But heck, COBOL is where the real money's at. Lisp is if you want to do like artificial intelligence and develop the next Skynet or something like that. And there are literally hundreds and hundreds and hundreds of languages around. So here we see a table going back to the 1954 all the way to 2011, and here we see how different languages are related to each other and how languages kind of evolve from one to another. Right? New concepts are being thought up, new abstraction layers are being thought up, and in a way, languages branch out, some languages die out at a certain point in time, but the main languages from the 1950s are still with us. So there's still people every day programming in C, there's still people programming in COBOL, and still people programming in Lisp because they have their own very dedicated fields. So why would you want to learn R? Do you know Robert Carroll? No, unfortunately not. Send me a link. Interested to learn about it. So why would you want to learn R, right? So the R language is free and open source. And as a Dutch guy, I love that. I love everything that's free. That's kind of our thing that we are known for. And it's open source. So that means that if I don't like anything in the language, I can change it. I can write code to change how the programming language works. I can submit it and they can change it, or they can accept that, or they can reject it. It is a language for statistical computing. So the language itself is built with an understanding of statistics. So it knows that there's a difference between a numerical variable and a categorical variable. It knows that there's a difference between like different distributions. It knows what a normal distribution is, what a t-distribution is, what a beta distribution is. It provides built-in graphics, which many programming languages do not. You can say plot something, right? Plot 1 to 10, and it will show you a plot. So that's built into the language. If you want to do something like that in C, that's going to be a lot of code to write. R itself is written in R, Fortran, and C, which means that you can use C to write really, really efficient code, You can write or you can use old Fortran libraries which have been developed in like the 1980s, and you can write things in R, of course. But one of the other big advantages is that it's operating system agnostic, which means that if you have something written in R, it will give you the exact same answer no matter if you execute it on Windows, on Linux, on Mac, or on your smartphone. And this is not true for many languages that are out there. Many languages are tied in a way to a certain operating system. Or you have to write code which is specific for Linux, you have to write code which does the same thing for Windows, and you have to write code which does the same thing for Mac OS X. So, but for R, that's not true. If you have R code, it will run exactly the same on each operating system that you use. Even on your smartphone, you can nowadays run R. It has built-in knowledge of linear and nonlinear models, which is really useful when you are modeling biological relationships or when you're modeling anything in general, right? So if you write statistical models, the language knows what a statistical model is. It knows what a formula is. It knows how to define these things. It has built-in help and testing, which is nice if you want to develop your own packages in the end, because if you want to develop your own packages, it's nice that it has a built-in testing framework to test that your code is still doing the same thing, even after you change a couple of lines of code. And one of the biggest advantages of R is that a lot of people in the world are using it. People who work in the financial industry, who work in AI development, people who work in biology. So there are literally thousands and thousands of add-on packages available. A quick scan learns that in the main repository, the cron repository for R, there are 4,000 plus packages. And then we're not even talking about all of the other packages which are available. So all right, then I think it's time to take a little break, and then we will continue. I can show you the look and feel, right? Nah, it's 3:12. It's not that long. It's a single live stream. On Twitch, we used to have like real breaks, but so a little bit about the look and feel. If I start R, I see this more or less. Well, not with the plot because I have to make that, but this is how it looks when you download the R GUI window. So this is, I think, on Windows 7. This is how R looks on Windows XP or older operating system. Again, very similar, right? So you have the input console. So here you type your commands, and you have a graphic view which allows you to make plots. Same thing here, you have your console, which inputs thing, and then here you have your output. So this is just a screenshot I made for one of the pictures. For some people, R looks like this. This is R Studio, which is a shell around R, which provides more things. Like it has the code editor, so it has a built-in editor where you can type code. Here it has the console, so this is where you type in the commands, and then those commands are interpreted by the R interpreter. It has, of course, a plotting window as well, but this plotting window can also be used to view the files on your hard drive and do packages. Does the download link you send us work on Windows 10 and 11? Yes, yes. Windows nowadays, it doesn't matter if you're Windows 10 or if you're Windows 11. They're the same thing. It's just that Microsoft is reskinning it and reselling it. But the nice thing about RStudio, the nice thing, I can have a whole rant on why I think RStudio is good or why I think RStudio is bad. I think RStudio is bad for when you're a starting out programmer, because like there's a little bit of an additional layer between you and R, right? Here you're very bare bones. You type in your commands and then you see what happens in the graphic window. But here it's all kind of click and play for some parts, right? You can go back to the previous plot. You can load packages by just clicking on them, and that I think is not good for basic programmers. But I don't care if you use RStudio or if you use the standard R GUI, even if it looks like this, because this is generally how I interact with R. So I generally interact with R via the Windows command line. So that means that you can just do R, it starts up R, and then you can type in your commands. And when you do a plot, it will open up another window which you can just click away when you don't need it anymore. Good. So R looks and feels very different in very different situations. This is the R term window. This is the R Studio window, which some people like, but I'm not a big fan of it. This is how my R generally looks like, but I use R a lot like this as well because it's useful when you want to use it on machines. Good. With that being said and done and the discussion going on, we will continue with R as a calculator, but we will first do a short break. So the first break, and all of the breaks are around 10 minutes. I will quickly run down, do a cigarette, and drink some coffee. Have my voice relax a little bit. And for you guys, I have prepared funny animated GIFs. So as is tradition, the first set of animated GIFs will be guinea pigs, because everyone loves guinea pigs, so why not? And I will probably start in some music as well, because otherwise it's so damn quiet. Here we go, GIFs. Yeah, GIFs, GIFs, GIFs. Good. So we will do some GIFs, and I will be back in around 10 minutes. Good. Alright, let me start it up. So let me start the music like this, and you can't hear it. Let me stop the music, unmute the thing. So now you should be able to hear the music, and then we will go to the first break. So I will be back in 10 minutes. Enjoy yourself and behave yourself, and see you in 10 minutes. All right, I'm back, guys. Let me read the chat quickly. Ooh. All right, so there's a little discussion about eating guinea pigs, feeding them to snakes, which you shouldn't do because they're nice and cute. Yeah, snakes don't eat cheese sandwiches. Peru, the country with the alpacas. Oh, alpacas will come in one of the other breaks, so that's good. Let me see any more. Does anyone have an issue with the Prüfungsbureau to register officially to this course? If you have any issue with registering, let me know what the issue is. Generally, if you are not from our institute, you need to have a letter from me saying that you can join the course. Something like that. Um, so that's generally the issue that they have because they want to make sure that there's enough space in the course. Um, Chicks and cows are nice and cute too, but that doesn't stop you from eating them. Yeah, that's true. That's true. That's true. But those guys are simply ignoring me like the plague. Yeah, that's another issue. I am well aware of that issue. They ignore me as well. Not like the plague, but sometimes they do. Yeah. Send me an email. I will see if I can contact someone since I'm working here. I might have a little bit more push to see if I can get you registered then. So good. All right. So yeah, that's something that we can kind of figure out in the coming weeks. It might be because of Easter holidays and stuff as well, because that of course always creates an issue with people being on holidays and these kinds of things. But in the last couple of years, I kind of learned whom to speak to directly and bother them to get a mail back. So I'll do my best to get you registered. So just send me an email so that I don't forget. All right, so let's start doing some R, right? So I haven't even used my fancy button thing here where I can just say, ooh, go to R and go back. So first things first, right? R is a very fancy calculator. So you can just type in whatever you want and it will compute. So for example, if I want to know what 1 plus 4 is, I just type in something like 1 plus 4. So I can do 1 plus 4 and, oh, no, that's 1, 2, 4, 1 plus 4. And it will tell me this is 5. Sorry, where did you send the download link for R? Oh, it's in the assignments, which are already online on Moodle. But the link, let me actually put it in chat. So if you're on Windows, then this is the link. There you go. Oh, that's wrong. Not that used to. So this is where you can download R. So this is our GUI, right? The one that I'm using. If you want to do R Studio, which is some people like it better. I'm not a big fan of it, but then you can just go to rstudio.com and you can download it from there. So those are the links at which you can download it. All right, so R is just a very basic, it's a calculator, right? So you can type anything in. Just remember, and that's on the slide, so let's go back to the slide. So just remember that the decimal point is the decimal separator, so doing 1.5, it is always a period, never a comma. The comma means nothing in R, and R will ignore commas and even in files. So it is one of these issues that we will run into when we start loading in Excel files, because Excel likes to localize your numbers, right? And in some areas of the world, it is 4,5, and in other areas of the world, the comma actually means 1,000. So if you write 1,000, you write 1,000. But in R, the decimal separator, always a period. And it will cause some issues, and then you will remember this slide and think, oh yeah, there's a comma in there. R doesn't recognize commas. 5 divided by 10 will yield 0.5, not 0,5. There are some special operators in R, like you can do exponents, so 5 to the power of 2. You can write it in two different ways, so you can use Shift 6 if you're on a US keyboard to have this little rooftop thingy, roof indicator. But you can also do just the two multiplication symbols behind each other. So 5, Shift 8, which is the multiplication symbol. 2 will also do 5 to the power of 2. And of course, this will yield 25. Then there are some special operators which are useful in computer science a lot, which is called the Euclidean division and the Euclidean division remainder. I have 2 slides about that to explain to you guys what Euclidean division is, but it is division by integers. So it makes it so that you divide, but if you divide and there's something left behind the comma, which is a dot in R, then it will give you another output. And of course, R comes with a whole bunch of built-in numerical constants which you have to be aware of. So if R tells you that something is ENF, that means that it is infinite. If it tells you NaN, it means that it is not a number. So that generally means that something is a character, right? If you do in R something weird like this and you say, I have the string called hello, right? And I want to do plus something like this, then it will give you just an error saying non-numerical argument to binary operator, but it sometimes gives you NaN, meaning that it is not a number. So that's just one of these things. So you have not a number, and the nice thing about R is R understands that because it is built on statistics, is that there are missing values. And it will deal with these missing values when you do computation. So the NA is missing. So 3 very special meanings. I think R also has minus infinite. So something can be positive infinite, minus infinite. It doesn't understand things like countable and uncountable infinity, but those are very, very specialized subjects in mathematics, which we won't get into in this course. But it understands what infinite is. So Euclidean division, right? So imagine that I want to divide 100 by 39, right? So then the way that we used to do this in elementary school, or at least when I was in elementary school, is just say, well, we write down the number that we want to divide between these brackets, and then we write down the number that we divide by in the other. Before that, right? And then the first thing that you would do is then you would see the first number 1 is not divisible by 39. So you would then say, okay, so then the next one comes in, so it's 10. 10 is also not divisible by 39. 100, of course, is divisible by 39. So how many times does 39 fit into 100? Well, it fits into 100 2 times, right? And then you will say, well, I have 100, and then the 2 times 39 is 78, which means that there's 22 left. And this is called the Euclidean divisor. So the Euclidean divisor means how often does a number fit wholly into another number. And then the Euclidean division remainder is how many units are left when we do this first division. Right? So in this case, it's 22 is remaining because there's still 22 units that we have to do. And this comes back when we start doing loops. So when you start doing loops, you want to, for example, use multiple cores on your CPU, and then you need to know how many batches can I do and how many do I have left, right? If I have 4 CPUs in my computer, then, for example, if I have to do 73 computation, right? So then the question is, how many times can I do 73? So how many units can I do per core, and then how many units do I have left? And it comes back into a lot of mathematical problems. But Euclidean divisor, Euclidean division remainder, those are things when you divide using integers, so whole numbers. Furthermore, R has a whole bunch of built-in character constants. It knows the letters, right? So if I type letters, then I get a vector which is containing the 26 uppercase letters of the Roman alphabet. If I type letters using small characters, then it knows that I mean the 26 lowercase letters of the Roman alphabet. Right? So if I go to R and I want to know what the fifth letter is in the alphabet, then I can just say letters and I do square brackets and I put 5 in between. So I'm saying here from the vector letters, select the fifth element. So, letters, sorry. So the fifth letter of the alphabet is E. The 20th letter, wouldn't know that by head, the 20th letter is a T. Right? So R knows this. Furthermore, it also knows all of the months of the year. So there are two things. So it is month.up, which is the three-letter abbreviation for the English month names, and you have month.name, which is the English name for the month of the year. So again, if we go back to R and we ask what is the months.names, is it month? It's month.names, and we ask what is the 10th month, month.name, sorry, then it says the 10th month is October. Right? So it knows a little bit about time, it knows a little bit about months, and that's really useful when you have to deal with, for example, times, right? So often in biology, we have a birth date and then we have a date at which the experiment started or a certain treatment was applied. So R can be used to calculate how many days are in between the day at which an animal was born and the day at which the animal went into an experiment. Of course, R also knows pi. I think everyone knows pi. That's the ratio of the circumference of a circle to its diameter. And the built-in constant is accurate till, I think, 128 digits behind the comma. So don't use 3.1415 when you want to calculate something on circles. Use pi. It is just a built-in constant. So typing pi will show you pi with a whole bunch of digits behind the comma. R also understands imaginary numbers. So imaginary numbers come into play when we want to calculate things like weights on a feather, which there's some kind of dampening. And in all kinds of mathematics, imaginary numbers come back, right? So we know that we can take the square root of a negative number generally. But in mathematics, of course, we have advanced calculus, and in advanced calculus we have the definition that the square root of minus 1 equals I. So you can have R use imaginary numbers, but then you have to specify that you want that. So if you say to R, give me the square root of minus 1, it will say this is not a number. But if you ask it for the square root of minus 1 plus 0 imaginary units, then it will tell you that the correct answer to the square root of minus 1 is 0 real units and 1 imaginary unit. So it can deal with imaginary units. Of course, R also supports all the basic trigonometry functions like the sine, the cosine, the tang, the arcsine, the arccosine, and the arctang. So those are just built in. And these are functions. So if I, for example, want to know the sine of 20, right? So then I can just say sine, round bracket open, 20, round bracket close, and then it will tell me that the sine of 20 is 0.9. So just a built-in function. And of course it can do the same for the cosine, and it can do arctang and these kinds as well. So there are these are built-in functions into R which you can just use. Furthermore, R has a good understanding of what logarithms are, so you can take the natural logarithm of 5 by using the log function. So this is when the base of the logarithm is 2.2 something. But if you want to have the base 10 logarithm of 5, then you can write log 10 and then 5. The inverse of logarithms are, of course, the exponents. So if I take the e value, so e to the power of 1, that is exponent 1. E to the power of 5 is exp5. So it has logarithms and exponents built into the language, which is really, really useful. So furthermore, when we are dealing with R and we're dealing with mathematics, right, then we have to know the order of operations. So the order of operations for mathematics is that we first do the exponent, then we do the roots, so the square roots or the triple roots or the four roots. Then we do multiplication and division, and then we do addition and subtraction. So there is this donkey bridge, we call it in Dutch, ezelsbruggetje. I don't know what you call it in German, but probably something similar, like a thing. So if you want to remember the order of operations, then it goes, please excuse my dear Aunt Sally. So it is subtraction, addition, division, multiplication, exponent, and roots, which is the E for, no, it's not, so because the P is for the power, E is for, it's for the inverse. We call it ezelsbruggetje 2. Okay, very good, very good. So if I write down these things, right, and I ask you what will be the answer when you type this into R, and these are all of these stupid Facebook quizzes that your aunts and uncles are always sharing about, then of course the answer to this is 4, right? Because we first do the multiplication, and then we say, so 3 times 2, which is 6, and then we subtract that from 10, and it's not 10 minus 3, which is 7, and then multiplied by 2, so the answer is not 14, right? That's just stupid, but like I see these things on Facebook all of the time because my aunts are very bad at mathematics, so they always mess up the operator precedence. Of course, brackets can change the operator precedence, right? If I would write this down and I would say round bracket 10 minus 3, round bracket closed, then it would do the subtraction first, right? So the operator precedence is like normal mathematics, but in case that it is confusing, use brackets, right? Brackets are really useful in that sense to kind of be explicit. And this is one of these things that sometimes goes wrong when you write your own code and you get like answers that don't make sense. But standard operator precedence, like in mathematics, also applies to R. All right, so in R, right, when we start the R window, we have a session. So by starting R, we get a session. And R, at this point in time, is started from a certain point in your hard drive. So if I want to know where I currently am on my hard drive, I can use something which is called, let me move here, get working directory, right? So I'm currently on my D drive. I could be somewhere else. I can say, for example, set working directory, go to my C drive, right? So now when I do a dir, right, for listing all of the files in the current directory, then it will tell me, well, on your C drive you have something which is called recycle bin, and then you have bioinfo 2021, which is the old course. I have a folder called GitHub, and of course I have a folder called Windows as well, right? So by using set working directory, I can move somewhere else on my hard drive or to a different hard drive, right? And get working directory will tell me where I am at this point, right? So get working directory, where does R save and retrieve files from? If I type dir, then it will list which files are located in the current folder that I am. I can use a set working directory, which is go to another place to save or load files. And then there's this ls function, and this tells me what is in the current environment. So in R, when I do an ls, and I don't think that I have that many defined, well, I have 4 variables defined, but I can define more variables, right? I can say number x, right? And then I can assign the value 10 to this. So now when I do ls, it will tell me that I have defined a new variable called number x. So ls gives you an overview of everything which R is currently aware of. So all the variables that you defined, all of the things that you assigned to a name. So just that you're aware that this is the session, right? And in R, everything is in RAM memory. So when I try to assign like a billion numbers into a variable, then R will run out of memory. Let me show you guys if I can actually force that, right? If I say bunch of numbers, right? And I say put all of the numbers from 1 to a million in there, right? Then that fits because I have 16 gigs of RAM, right? But then if I would do even more numbers, it still fits. But then if I would do even more, right, then at a certain point it will say, oh, result would be too long a vector, right? So that would mean that it would not fit into my memory anymore. So it just gives me an error saying that I can't do that. So you have to be aware that you can't create an infinite amount of variables, right? The memory that R uses is very limited. Is limited to the amount of memory that you have in your computer. So be aware that that is one of the limitations of R and that you have to deal with that, right? You can't load in a 50 gigabyte file when you only have 16 gigabytes of RAM. I told you that R comes with literally thousands and thousands and thousands of packages. So for example, there are packages to do QTL mapping. So QTL mapping is a method to find regions in the genome which are controlling classical traits, right? And there's a package for that. So if I want to install a package, then I can say install.packages, and then I say between quotes, because I have to give it a string, because otherwise, if I would not give it the quotes, it would say QTL is not found, because it would look for a variable called QTL, which is not defined. So these air quotes, they are strings. So a special data type that you can use to store text. So here I'm just going to say install a package called QTL, right? And this will go online, look at the online repository, see if there's a package with that name, and then install it into your R version. If I want to use a package, I have to make it active. So I have to say library QTL. So this will install it. You only need to do it once, but every time that you start R, you have to load your package. So you have to make it active. And so, for example, thinking about things like multiple sequence alignment, there is a package MSA which allows you to do multiple sequence alignment. So you have to first install the package, and then when you want to do multiple sequence alignment, you just say library MSA, and it will give you then a function to do multiple sequence alignment. And of course, like I said, there are like 4,000, 5,000, perhaps even 12,000 packages. So hey, you can just search for what you want, right? If I want to do machine learning in R, then hey, I can just search on Google saying I want to have a package in R which allows me to do machine learning. Again, you find the package, you say install the package, give it the name of the package that you want to install. This will download the package from online, put it on your computer. If you then want to use this package, you have to still type library QTL to make the package active. If you want to save something to the hard drive, so for example, I just defined this variable, right, called number x, right? So if I type number x, it will tell me this contains 10, and I can save this. So I can just say save number x and save it to something which is called my number x.r data, right? So now it will, oh, sorry, I have to say file is. I have to specify the name that I want to save it, right? I get a warning message, and that's permission denied, because if I do my get working directory, I'm actually at my C drive, so I'm not allowed to save things on my C drive because of the way that my Windows is set up. And I can go to my D drive, I can save stuff in my D drive, and then I can say save number X, and then it will now create a file on my D drive called my number X.r data. If I now clear my session, right, so if I now say number X is NA, right, so now when I type number X, it has no value, and now I can just say load, and then load in my number x.r data, and now it loads in from the file on my hard drive, and now when I type number x, you can see it has the value 10 again, right? So if you want to save stuff to your hard drive, then you can use the save function. If you then want to reload it, then you can use the load function. Good. Then there's another thing. If you want to just save everything, right? Because I just did this ls function to show or to see, and it seems that I have more than one variable defined. I actually have like bunch of numbers, number x, offset x, sleep, and offset I. For some reason, I probably started R before I did started the stream. But if I just want to save all of them, right, I can use the save.image function. Then I don't have to specify what I want to save. I can just say save.image your.r data. If I want to quit R, I can press the button on the top, right? And then it will ask me, do you want to save your workspace? Do you want to save your session? Always answer no, because the next time that you start R, it will load in every time everything that you had defined. And this is generally not what you want, because this means that if you load in a 4 gigabyte file, then the next time that you start R, it will take like 10 minutes because it has to reload all of that stuff from your hard drive. So when you quit R, don't save your whole session. If you want to save stuff, do it explicitly, right? So say save or save image, but don't do it when you're quitting R, because sometimes you have a lot of data loaded, and that would mean that by quitting, it saves it to the hard drive. Then the next time you start R, it starts loading in everything, which can sometimes make R take like half an hour to start up. All right. I told you guys one of the advantages of R is that help is available, and there's a lot of help available. So hey, you can say question mark function name, and then it will open up the help file for that function. So let's just give an example, right? So if I go back to R and I say give me the help of the function called sec, right? Sequence, which is a function that allows you to make a sequence, right? So I can say sec 1 to 100, go by 2, right? Then we'll do 1, 3. So that's just generating a sequence. If I want to look at the help file of sec, I can just do question mark sec, and then I hope, no, it opens it in the wrong window, but that's okay. That's just because I'm streaming that it does that. So then it opens up the help file, and then for you guys it will look like this. Right, so now it opened up the help file saying that sec is something which is in base R, it is sequence generation, and it just says generate regular sequences is a standard, blah blah blah. It has the usage, and then when I scroll down, it will actually give me an example. Right, so I can say sec 0 to 1, length.out is 11, so split the range from 0 to 1 in 11 equally long parts. You can use by, so it just gives you a little overview, and it gives you a couple of examples at the bottom. So the good stuff of the R help files is always at the bottom. If you use this function, for example, in your publication, then here it also gives you the reference. So it also tells you, well, you use this function. This function was made by R. Becker, J.M. Chambers, and A.R. Wilkes, and this is the book that you have to cite. So in this case, it's a book, so there's no DOI or no journal, but it's called The New S Language, and it was the Watson, Brooke, and Cole was the so hey, it has all of these. It has all of this information for you. So that's really useful. So by doing question mark sec, I get the help file for the sec function. If I don't know exactly what I'm looking for, and I'm thinking like, no, I want to look for something called, for example, the standard deviation, right? I can say search for the term deviation. So I use the double question mark, then I give it the term deviation, and then it will search through all of the help files that are there, and then every file that mentions the term deviation will be listed here. And then of course I can click on it, and then it will give me more information about it, right? So variance and standard deviation of a vector. So that's probably what I want. Or I can, for example, surface area. But so I can search for the help through the help files, and that's very useful when you don't know exactly what the name of the function is that you should use or that you're going to use. All right. Let me switch back to PowerPoint. So of course you can search for terms like obesity, and remember, you can even get the help file of the plus function, right? Because every function in R has a help file. In the case of plus, you have to do the quotes around it, hence to make it a string. Otherwise, it would be a syntax error because question mark plus could mean something else. So, but the plus function also has a help file, just in case you forgot how addition of numbers work. So use it a lot. It's really, really useful to just look at the help files. And it always gives you a small example at the bottom that you can just copy paste in and see what happens. All right, data type. So now it starts getting serious because this is something that you need to understand how R works. So in R, types are separated into different types of data. So for example, you have a data type which is called logical. So a logical value is something that we consider to be true or false. So a variable which is a logical variable can only have two states, right? It can be true or it can be false. There's no other option. It's not a quantum computer that we're using. We're just using a classical computer. So a bit in the computer can be on or it can be off. Furthermore, we have numerical values, right? So 5, 7.9, 10.6. Those are numerical values. In R, we have a type called character, which is badly named because it's not a single character. It's actually a word or a line or something. It can be more than a single character. It can be a whole piece of text. But a character is something which starts with a double quote, then you have something, and then it's double quote end. Right? So everything between the two quotes is interpreted more or less literally and is just stored in memory as being a character. Because we are dealing with a statistical language, R has something which is a vector. So a vector is a list of things, and this list of things has to be of a single type. Right? So I can, for example, say C, which stands for combine. So combine these numbers together in a vector and then store it into V1. Right? So let's just show you guys how that works by using R. So in R, I can say, for example, I have some numbers that I measured. So I have my measurements, right? Measurements. And my measurements are, well, the first animal had a measurement of 10, the second 12, then there was an animal of 11, then there was an animal which has 9, and then there was an animal that had like 80, right? Just random measurements, right? So now if I type measurements, it will show me, okay, so these were the measurements, right? So this is a list of things. You can do the same thing with characters. And you can do the same thing with logicals, right? So a logical vector is, for example, true, 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 and false. R has built-in matrix support, unlike very, very different languages. Like a language like Java has no built-in matrix function. It does not understand what a matrix is. But because R comes from a statistical mathematical background, it knows what a matrix is. So a matrix is a two-dimensional array like a Excel file. So a single sheet in an Excel file is more or less a matrix because you have rows and you have columns. Right? So if I want to define a matrix, I can use the keyword matrix. So I can say make a matrix containing the numbers 1 to 20. So the double point is kind of a shorthand for writing 1 to 20. And then give it 5 rows, 4 columns. Right? So this will create a matrix which has 5 rows, 4 columns, and it contains numeric values. Again, in R, a matrix is always of a single basic type. So you can have a numeric matrix, you can have a logical matrix, or you can have a character matrix. But you can't have one column being numeric and another column being logical. That's not allowed. In R, basic types, vectors, and matrices are always required to be of one type. And this comes back when we start loading in our own data and formatting our data for R. Because in general, when we measure things, we don't measure, we measure things in, for example, a numeric way. But we also use characters, right? Because we say that this animal belongs to group 1 and it has a measurement of 10. So in R, you can't load this in as a matrix. But let's just create a very basic matrix, so just that you guys know. So I can say matrix, right? 1 to 20, give it 5 rows, 4 columns, and then it looks like this. So the first thing that you observe is that R fills it on a column basis, right? So the first numbers, so 1 to 5 go into the first column, 6 to 10 go into the other column. If you don't want this, if you want to fill by rows, right, you can say comma by row is true. Oh, sorry, that's all small letters. By row is true, and now it fills per row, right? So it says 1, 2, 3, 4. Right, so there's two different ways of creating a matrix. The standard way is taking the numbers that you gave it and filling it column by column. If you want to fill it row by row, then you have to specify by row to be true. All right, so generating a matrix. So if you want to work with types, right, because you need to sometimes know how many measurements there were, you can ask for the length. Right, so if we go back to R, I defined my measurement. So if I ask for the length of measurements, then it is 5. So there are 5 numbers in my measurement vector. So the length. If you have a very complex object, which is possible in R, you can use str. So str will show you kind of a graphical representation of the structure. We have no complex objects yet, but let's just show you the str of the measurements, right, like this. Then it says it is a numerical vector. It has 5 elements, and then it lists the first, it lists the elements afterwards. So, but of course, like you can have a list with a list in there, and then a matrix in there, and then these structures become more useful. But at the moment, because we're only dealing with basic types, it would just tell you, well, it is numeric, it has a length of 1 to 5, and these are the values inside of it. The class will tell you what class has been assigned. So class will tell you this is logical, numeric, or character. You can force things to be numeric, right? So you can go from a character representation to a numeric representation, or from a numeric representation to a character representation by using as numeric or as character. So let's show you an example of that. So for example, if I have the string 1, then I cannot add something to it, right? Because it will say this is an error. You have the character 1, and you're now trying to add a numeric value to it. Of course, we can convert this 1 from a character representation to a numeric representation by using as.numeric, right? So convert this character 1 to a numeric representation, and now it is able to understand what we want. So now we go from a character 1 to a numeric 1, and then we can add another 1 to it. And then the answer will be 2, because 1 plus 1 is 2. We can also ask the question of something is numeric, right? So is.numeric, right? So if I have a certain string or a certain character loaded, then is numeric of 100, right? This will be false because it's a character, right? But if we ask is numeric 100, then it will tell me true. And this also works for vectors, right? Or matrices for that matter. So if I define my matrix, right? This is a numeric matrix. I call this Y, right? If I now ask is.numeric Y, it will tell me yes, Y is a numeric matrix. If I would do something else, right? If I would create a vector containing 1 and 2 and then hello, right, which is perfectly fine, right, because they're all characters. I can put them in my car v, so my character vector, and now I can ask, is this thing numeric? And it will say no. I can ask, is it a character, right? Then it will tell me yes. So just you can ask questions about what is in a variable. Alright, so working with types, very important. We will come back to it, and it'll be fun, because this is going to screw you over every time. Like, it even screws me over. After programming in R for like 16 years, the type system in R is massively complex. And it will screw you over. Definitely. Like, it happens all of the time. Alright, so when we want to create vectors and matrices, we already saw a couple of these, so we can use the C, the combine operator, right? And then we just say 1, 2, 3, 4, 5, whatever we want to put in, right? So we can see things together, then it will create a vector out of the individual objects. We can also use the sec function to create a sequence which goes from something to something by something, right? We already saw this with the sec 1 to 100 by 2, right? So let's just give you an example. So we go sec from 1 to 100 and step by 7, right? So it will say 1, 8, 15, 22. We can also use the rep, the repeat function, and then we just repeat a single object a number of times, right? So I can say, oh, that's the wrong button. I can say repeat the letter A 10 times. And then it just gives me 10 A's. So very, very basic functions, but gonna be very useful at a certain point in time. Because when we start having like conditions, then you say, well, the first 100 animals were in condition 1, and then the next 50 animals were in condition 2, and then you can use the rep function to generate a vector which has the length that you want. Matrices we also already saw, so we can create a matrix by just giving it a vector object and then saying how many rows and how many columns there need to be. We can also use cbind and rbind, and these are really, really useful functions because I can take, for example, two vectors of the same length and cbind them together. So what it will do, it will just create, so if I have two vectors of length 4, it will take the first vector as the first column and then the second vector as the second column. Rbind works the same, but now for rows, so it will take the first vector, make it the first row, and then it will take the second vector and make it the second row. So for example, if I want to have an empty character matrix, I can say M is a matrix, use the empty character string, right? So just quote, double quote, right? That it's a string which there's nothing in there. I could have used the A as well, but then I would have a matrix which is not empty but filled with A's. And then it will generate a matrix, in this case, 10 rows, 10 columns. So M is matrix, empty character, 10 by 10. So some examples, V1 is 1, 2, 4. So this is shorthand, right? The double point, it just means 2. So 1, 2, 4, stepping by 1. So that's just 1, 2, 3, 4. I can use the sec function from 1 to 100, stepping by 7. I can use the repeat function, so repeat the number 1 4 times, so I will just get 1, 1, 1. I have V4 here, which is just repeating the letter A 4 times. The same thing I can do with matrices, so I can say M1 is a matrix, character matrix, so empty character 10 by 10. If I want to create a numerical matrix, I have to use NA, right? Because it's an empty matrix, but the empty numeric is called NA, missing, right? So this is just a matrix which has 10 rows, 10 columns. All of the values in the matrix are missing. I can take a cbind function, so I can say V1, V3 is column bind them. So let me just show you that in R, right? So I can say V1 is 1 to 4, and then I say V2 is repeat, for example, the number 10 4 times, and now I can say cbind V1 comma V2, and then you will see that the first column will now be 1 2 3 4, the second one will be 10 10 10. And if I would use the rbind function, then it would do it the other way around. So it will now put the first vector in the first row and the second vector in the second row. Good. And I know this is a little bit boring, right? Because like it's just how do you do these things? But it is very, very important to really understand what's going on when you're dealing with vectors and matrices, because they will be everywhere, right? If you load in your own Excel file, then all of a sudden you have a matrix, right? And you need to select certain columns from it because you want to know what is the average of a certain column. So then you need to be able to select that column. So how do we select things? Well, if we already saw this in R, so when I type R, it will give this number here, right? And let me switch back. That's what it does here, right? So this is 1, right? So this is the first A in my vector. So when I have a very long vector, right, which is not just 10, but like 100, right, then it will say that, well, this is the first one, and this is number 16. So it helps you directly by displaying where in the vector you are. The same thing holds for the matrices, right? So here it will say that here I have the first column, second column, third column, and fourth column. Same thing for the rows, but in this case, since I used vectors which have names, it will use the name of the vector as the row name in this case, or as the column name when I'm using cbind. Right? So it's just these indexes here. When you type something in R, it generates auto indexes for you, so you know how to select from the thing that you just created. So if we index a vector, we use the square brackets. So here, for example, I have a vector which contains the first letters of the alphabet, and I can select, for example, the fifth letter from the alphabet using phi square bracket open 5 square bracket close. So if I'm selecting from vectors or matrices, you use square brackets. If I'm calling a function, like the sec function or the repeat function, I use round brackets. So I can also use a trick, right? So I can say from V, select the letters 2 to 5, right? So then it will select B, C, D, and E. And I can use the combine vector, again, to say, well, select from vector V. You always read from the inside out. So combine the numbers 2 to 5 with 8, and then use this as the index to vector V. Right, so I'm saying C, so call this combine function, combine the numbers 2 to 5 together with 8, and then select it from the vector called V. So then it will select for me B, C, D, E, and then the letter H. Good. We will practice this really hard during the assignments, because this is the thing that if you are able to wrap your heart in R, indexing starts with 1. That is a very good observation, Leonardo. Yes, that's a +1 for you. Yes, because R is based on statistics and mathematics, things start with R. If you think about mathematics, if you have a matrix, then the first element of the matrix is at row 1, column 1. This is different from many other computer programming languages. Computer programming languages like C are generally counting from 0, and that's the difference between someone who does computer science and someone who does mathematics. A computer scientist counts to 10 doing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But a mathematician counts to 10 by saying 1, 2, 3, 4, 5, 6, 7, 8, 10. So a mathematician is like a normal person. A computer scientist is like a crazy person who just happens to count from 0. Right? And this goes wrong a lot. And especially if you're used to programming in another language, these off by 1 errors are very common when you come from another language and you start programming R. But this has all got to do with statistics, because in statistics, the first measurement is called measurement 1 and not measurement 0. So because of R being based in statistics, we count from 1. So very good observation, Leonardo. Very good observation. All right, so for a matrix, we have the same thing, right? So from a matrix called M, select the first to the third row, comma, column 1, right? So it will select this thing. So it will give you back a vector which has the numbers 0.76, 0.299, 0.211. I can also say from the matrix, select from the fifth row the columns 3 to 6, right? So then it will select this area here. So it will give you back a vector which has a length of 4, containing these 4 numbers. You can also select a single element, right? So then it will give you back a singular element, not a vector. So from the matrix, from the 8th row, select the 7th column. And in R, you don't have to specify what you want. So if you just want everything, right? If I want to have the whole 9th column here, then from the matrix, do a comma, right? So because I don't specify anything for the rows, it will automatically give me all the rows. So from the matrix, give me column number 9. You can do this for the row as well, so I can also say M9 comma, and then it would select the 9th row of the matrix. So not specifying anything means give me everything, which is also a little bit counterintuitive. All right, so just to repeat, there are 3 basic types in R for now. We have the logical, which can be true, which can be false. We have the numeric value, which are numbers. Numbers always have a dot as a separator, never a comma. We have characters, which are 1, 2, 3. And then we have a vector. Vectors are an array of things which are all of the same type. And we have matrices, which are the same as vectors, but they are two-dimensional, and they are also all of the same type. So to make it a little bit more complex, right? Because I told you that the R-type system is really, really difficult. We also have something called a data frame. So a data frame is like a matrix. It's a two-dimensional structure, but it can contain multiple basic types in the columns. Not in the rows, but in the columns. So if I have a vector of length 4 containing numeric values 1, 2, 3, and 4, I have another vector which contains character values red, white, red, and missing. And I have v3 which contains logical elements. If I want to put all of these together into a single thing, right, into a single two-dimensional matrix or two-dimensional data frame in R speak, then I can use the data frame function, give it v1, v2, and v3, and then store this into a variable called d. And now D is not a matrix, it's a data frame, and it is allowed to have multiple types in the columns. So this will just say V1 is the first column, V2 is the second column, and V3 is the third column. We also have a list, which is not a vector. Again, a list can contain multiple types, but it can contain anything, right? So I can say make a list, and the first element of my list is Fred, a character vector containing the word Fred. Then I have the next thing in my list is actually a vector of v1, and then the next one is a numeric value which is designated age. And now it becomes really complex, right? So now you can see where the str function comes in. So let me just make you a quick list, right? So I can say a list. I say the name is, let's just do the thing that is there. So name is Fred, numbers is v1. We probably have a v1 defined, and then let's just put the matrix in, right? So say y, which was this big matrix that we made. Question from Zoom: is it also possible to put a matrix with 3 or more dimensions? Like, yes, but not using the matrix function. That is very advanced, and that will come all the way at the end. In the first 10 lectures, we're only going to deal with vectors and two-dimensional matrices. But yes, R supports n-dimensional matrices as well. So you can have as many dimensions as you want. It just makes it more complex. So we're not going to deal with that today. So here we see that I can create a list, right? And let me name the last thing as well. So this is matrix, or my matrix is like this, right? So now I create a list. The first element of the list is called, it has the name and is called Fred, or that's what it contains. We have numbers in there, and then we have my matrix in there. So if you want to build really, really complex objects which hold different types together, or even matrices, then you can use a list. Let me store this somewhere like D, right? Or not D, but call it my list. And now if I use str of my list, now it will tell me how this list looks like, right? So it's a list of 3. The first thing has a name, has a name called name, and then it is CHR, so it's a character, and this character has the value Fred. Then the second element of my list is called numbers. It is of type integer in this case, not numeric, because they're whole numbers. So if I would, there's a difference between integers and numbers with a decimal dot, because of the Euclidean thing. And here you will see my matrix, which is of type integer because they're whole numbers, and it has 5 rows, so 1 to 5, and it has 4 columns. So this is where the str function comes in handy. All right, so we have a data frame for when we have a matrix and each column has a different type. So this is more like a real Excel file, right? A list is kind of a combination of things, and these things can be anything, be it characters, be it vectors, be it matrices, being even lists. I can put a list into the first element of a list, which just makes it more complex. In R, we also have a type called factor, and this is the factor type. And the factor type is the type which is understood to be of a categorical variable. And this is again because of statistics, because in statistics we have, for example, males and females. And well, nowadays there's more than just males and females, but imagine biologically speaking, you have sex, and based on your chromosomes, you can be a male, X, Y, or you can be a female, XX, right? So, and R now understands that when I say as factor, so I say repeat the word male 20 times, then combine this with repeating the word female 30 times, so I create a vector of length 50. The first 20 elements are male, the last 30 elements are female. I combine these together, and now this whole vector I cast to this special type, to this factor type. Because when I do statistics and then I, for example, want to do a t-test and I want to compare the males with the females, right? Then R now knows that, okay, this factor has 2 levels and it can only be male or it can only be female. And it prevents me from adding a third random type into the gender vector. It's not gender, it's sex in this case. That's a bad, let me make it say. Gender is... change that to sex, right? Just not to upset anyone. So factors are categorical variables. And this thing we've already seen a lot, right? So if you write a hashtag in R, then this is a comment. And comments are always ignored by R. So if you use a hashtag, everything after the hashtag is ignored. So when you write scripts or when you write your answers to something in a script, use the comment symbol and then write, and use comments a lot. So hashtag are comments. Good, so those are more or less all of the things that we have. How am I going to want to do this? Because I think we should first take a break, because I've been talking for like an hour and 10 minutes again. So let's go to the second break, and then after that we will have a type test. So I will show you something and I will ask you what type does it have in R. So prepare for a self-test, get behind your keyboard, get excited, and we will see how well I am able to trick you guys. And the R type system is tricky, so we will try and trick you guys. And Misha, you're not allowed to join. Because you already saw it probably last year or during the bioinformatics course. So we're going to have to deal with that. Yeah, quick break. Again, 5 to 10 minutes. I will run to the toilet, do a quick toilet break, and then drink a little bit of coffee. You guys get more animated gifs. I think this time it is going to be, how are they called again? The chupacabra, big animals, the French-shaped animals. They are called French-shaped animals. Yeah, my moderator knows all the answers too. French-shaped animals. They are Well, whatever. You will see which animals. Capybaras. That's it. That's it. I've been talking too long, so my sugar level is getting low. Should get a bite of chocolate as well while we're at it. So yeah, I will be right back. So see you guys in 5 to 10 minutes, and enjoy the capybaras, not chupacabras, capybaras. Good. So be right back. Made it back in time. Made it back in time before the end of the music. I had to run through the building. Anyway, good. Welcome back, everyone who's still there. Get a piece of paper or use your computer. We are going to do a type test, I think, if I didn't put in another slide. So, type test. All right, so here I list 1, 2, 3, 4, 5, 6, 7, 8. So put the numbers 1 to 8 on a piece of paper and write down the different types of the things that are listed here. So I'm gonna start in a little bit of music because it's 8 and you probably want to think a little bit about it. So let me know when you have written down the types of these things, and then we will discuss them. And I'm going to see how many of you I got to trick with the R type system. So let's do another little music thingy. Let's do Pocket. We haven't done that yet. So hope I can talk above it, that it's not too loud. So you guys have like 7-ish minutes left to come up with the types. And just let me know when you're done. Just throw in chat, I'm done. Also you can do that of course in the Zoom. I can just... It's nice that I don't have to say anything. That is really loud in my headphones. Alright, how's it going? Are we still enjoying the art course? As a warning, there will definitely be a question like this on the exam, and I will do my best to trick you guys. It's only going to be 1 point of the whole exam. The exam will have 42 questions. That's kind of how I roll, so there's always 42 questions. 42 is the answer to life, the universe, and everything. So also to the exam, 42 is where it's at. Alright, anyone done yet? Where can I find the password for Moodle? It should be in the email that I send around on Monday. The password for Moodle is rcourse 2022. So, like this, with the R capitalized. So that's the key for Moodle, both for if you are having a Moodle account, if you are a guest, for example, from a different university, and you don't have a Moodle account at the HU, then you can use this for being a guest. So, but if you weren't in the Moodle, drop me an email, because then I need to check and make sure that you're in there. And it's not professor yet, it's just doctor. So, in Holland we don't do titles anyway. So, but in Germany they're big on titles. So, professor would be wrong; it would just be doctor. Can I do exam? Misha, no. You can't do the exam. Not saying that you're too old for it. Not saying that, but Isn't this the second time that you're following the course, actually? Crap. That's fine, that's fine. Like, in the end, it's not about getting the grade, it's just learning how to program. That's it's its own reward, right? Being able to program. Good. All right, so around 3 minutes left, so we're just gonna sit here and for copyright-free music, it's actually pretty good. That I was expecting that it would be much worse, but all right. So anyone done yet? Because I didn't see any yes or thumbs up or something like that yet. All right, first one finished. I'm really curious, Leonardo. Very curious how often I got to trick you. Because I do my best always with these kind of questions. I'm done with not knowing the answers. All right, that's like that's good as well. Well, it's not good, but it's also not bad, right? Like generally people, especially since we just discussed it, right? It's difficult, but it's gonna be fun. It's gonna be fun. Done. All right, Kianwei Shi. I'm probably horribly mispronouncing your name, so don't blame me for that. Like, I'm not. All right. So 1 minute-ish left. Let me actually check the Moodle. No, not the Moodle. The Zoom. So there's still a couple of people in Zoom. Didn't get any Zoom yeses. Gonna do my potatoes. All right, Misha. See you next time. Yeah, I'm getting hungry as well. But we have like a couple of slides left after this. So after this, it's like 8 slides, and then we're done. So it's not going to be much more. I just want to introduce you guys to the type system. And the assignments will go and have you practice a little bit with the different functions, like the combine function, the sec function, the repeat function, creating a basic matrix. Oh, you can still listen. Oh, that's perfect. That's perfect. Ganz richtig. Jan Wei. Well, that's good. That's good. Learned something new today. All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and pens down. All right, so first one, who wants to get a shot at it? What is the type of this one? Just throw it in chat. What do you think it is? And I know it will take some time. Like there's a 30-second delay. I don't know why the delay on YouTube is so much worse than the delay on. Wow, wow! You are so correct. You are so correct. Character, indeed, indeed, because of the double quotes, right? That's why it's a character. All right, so that's a 1 for you guys, 0 for me. All right. Interesting, interesting. All right, second one. So the type of this one, just throw it in again. All right. Davida, second one too. Also character with a question mark. Yeah, no, it's the double quotes. So it's a character. So very good, very good, very good. That's 2 for you guys, 0 for me. All right, what's the third one? Um, Very, very good. All right, so the Zoom came in first. Zoom says numeric. What do the guys on YouTube think, guys and girls? Numeric with a question mark. Vector, if that's anything. No, a vector is a vector is of a certain type. It's not that a vector is a type in itself. It's kind of a storage unit, right? So a vector is just things with multiple slots. You don't have to retract your message. Like no one thinks any less of you because of it. But yeah, indeed, it's a numeric value. It's just written down in scientific notation. So that's just the way that R rolls. So R understands scientific notation. So this is a 1 with 11 zeros behind it. So very good. All right, fourth one. 0x89. What does R make of this? What does R make of this? And I hope I'm still audible because again YouTube is throwing all kinds of errors my way saying that the audio stream bitrate is lower than the recommended bitrate. But I think I'm still audible. So alright, on Zoom we get Ditto. Rolando Riviera character. An error, like the X is meaningless right there, question mark. This is actually a numeric value. It is a hexadecimal value. So when you write 0x, it means that you're not using a 10 base system for counting, but you are using a 16 base system for counting. So 0x0f is also valid. Let me guys show you that because that's actually pretty funny in R, right? So if I write 0x0f, right, then this is 15. So, and that's the way that hexadecimals roll. So it also understands hexadecimal. And of course, if we ask for the class, then it will just tell me that it is a numeric value. So good. Interesting. So you guys are doing very, very well. No real tricks yet. So next one. This one. What is the type of this? All right. First answer on Zoom is in. You are correct, Shia Rolando Riviera. Unfortunately, you are not. All right, and on YouTube, people are also understanding that this is indeed a comment. Anything that starts with a hashtag is a comment. In many other programming languages, this would be a color. Like in HTML, this would be a color which has full red, no green, and half blue. So it's kind of a mixture. So, but R doesn't recognize colors in this way. So this is indeed a character. Not a character. This is indeed a comment. Good. Perfect. All right, next one. This one should be relative. In my window, there's a comment that slow mode is active. No, that's just to prevent someone from spamming, like, go to my porn site like hundreds of times per second. So the hashtag makes it a comment. Yes, everything after a hashtag is ignored by R, meaning that you can write whatever you want. So after the hashtag, it's a comment. Yeah, the slow mode is on just means that it's 5 seconds. So you can type message because sometimes it happens that someone has a bot and they just spam like visit this website or buy bitcoins, and then it rolls around the screen 100 times, and then when I block them, so just to prevent that, you can say anything that you want, but you can only say it once every 5 seconds. All right, logic. Yes, this is a logical value. All right, and then the two that are, I hope, going to be tricky. If not, then it's going to be an easy exam for you guys because you are almost having 8 out of 8, 7 out of 7. All right, so the next one, as factor true. What is the class of this? What is the type? All right, we are now getting interesting questions. So we're getting answers like functions. We didn't do functions yet. Oh, on Zoom we have one which is correct. Factor. This is a factor. I take a logical value and I convert it to a factor, because as factor means that make a factor out of the value that I give it. So the as factor will always return a factor, because that's what the aim of the function is. Um, so factor. Good, last one, and then we have a couple of slides left, and then we're done for today. So is character 1e plus 11? What is the type? What is the type of this? All right. On Zoom, I'm seeing good answer, Orlando. Good answer. Good answer. That is indeed correct. Leonardo says logical. Siavash character. Yeah. No, this is a logical, right? Because is character asks a question, right? So the answer to this question will be true or it will be false. And the type of true or false, doesn't matter what the answer is, right, is going to be logical. So the answer to is character is in this case true, and the type of true is logical. So, all right. So just quick recap. Character, numeric, comment, logical, factor, logical. Interesting, right? It's just something that you have to deal with, and the exam won't be that much more difficult, but I will do my best to trick you guys. And that's the only trick question that's going to be in the exam, I promise. Because the other questions are not going to be any trick questions or something like that. I'm not like that. But this one, I always try to come up with being as creative as possible, to make it as hard as possible for you guys to reason about what the type is. But you guys did very, very well. That's like 8 out of 8 for a lot of people. So yeah, you are paying attention, even though it's an online lecture. That's very good. All right, so we talked about the list, right? So that the list can contain anything and that you can put in whatever you want. So I gave you this kind of an example where we make a list where we have a character vector of length 1, with the name and the content Fred. Then we have numbers, with the name numbers and then 4 numbers in there. We then have another number vector of length 1, 5.3. And then we have a matrix. So in the last position, I now put a matrix, right? So this is a 2 by 2 matrix, with 0, 1, 1, 0, 0, 1 in there. So if you want to select things from a list, you have to always use double square brackets. And that is the only time in R that you use the double square brackets. So when you are selecting from a list, you can either do it by name, right? So if I say W dollar numbers, then it will know that, okay, so from W, select the thing that has the name numbers, and then in this case combine 2 and 3, which means select the second and the third element. If I want to select the first thing, right? If I want to select Fred and I don't want to use the dollar name, I can just say W, 2 square brackets open, 1, 2 square brackets closed, and then select the first element. Because although it is a single character value, in R it's still stored as a vector, right? So I still have to say select the first element from it. If I want to select from the matrix element here, then it is W4, right? In between 2 square brackets, comma 1, and comma 1 means select all of the rows from the first column. I can also just use this W dollar matrix 1 comma. So when dealing with lists, my advice is to always name the elements of the list. So say something is, so give it a name. So say element 1 is Fred, element 2 is, because it just makes it easier to select from a list. Sometimes you run into issues or you deal with a package and this package doesn't name the elements of a list, and then you are forced to use the double square brackets. So this is the only time in R that you use double square brackets, and that's just difficult. And it's the way that it is. I can't change it, but this is the way that you can select or index in a list element in R. All right, so there are some additional functions that I did want to introduce because they come back in the assignments. So we have a function called nrow, right? So nrow, round bracket open, and then when we give it a matrix object, right? So something which is of type matrix, it will tell you the number of rows. The same thing holds for ncol of a matrix, that will tell you how many columns there are in a matrix. And this will be very important when we start looping, right? So when we start going through every row in the matrix, or we start going every row in the matrix, or when we start going through every column in the matrix, right? Then we are going to use n row and n columns, because we're not going to hard code it, right? That's bad. We're not going to say for x in 1 to 6. We're going to say for x in 1 to the number of rows of the matrix. If we want to know the row names or the column names of a matrix, we can use the row names function or the column names function, and we can also use these functions to assign row names and column names to a matrix. So let me quickly demonstrate that for you guys, because I think we have a matrix, right? We have y, which is our matrix. So I can say, for example, row names of y is, and then I can say row 1, then I can say row 2, row 3, and then say R4, just because I'm lazy, and then R5, right? So now when I print my matrix, you can see that it now has row names. I can do the same thing for column names. So let's assign some column names as well. So I can say the column names of y is repeat, no, not repeat, is a sequence from 5 to 10. No, 5, it's only 4, so it's from 5 to 9. How do you mean it's not, what? Sec 5, 9. Oh, that's way too much. 5 to 8, sorry. 5 to 8. All right, so now when I say y, right, and now I did something very, very dumb, because now I gave numerical row names to this matrix. So now when I say select, so now I can do y and then give me 5. And then it will give me the first row. So that's dumb, right? So if you use row names and column names, always make sure that it's logical, right? So not that you start renaming rows, saying that row number 1 is actually called 5 and row number 6 is actually called 2, right? That will just make life harder on you. So always when you do something like this, right, where you say I want to have a sequence from 5 to 8, you can use things like paste 0 to say measurement or something like that, and then combine that with this, right? And now when we look at y, then every row will now, or every column will now have a real name. So when you do names, make sure that the names start with a character and that don't assign numeric names to a matrix. That's just making your life harder than it is. But row names and col names are really, really useful because you can use them to directly select from your matrix. And also when you want to combine two matrices together, when they have the similar row names, you can just merge them in one go. But hey, you can use row names to get the row names, but you can also use row names to assign the row names. And then one of these little tricks, you have the T function, which is transposing a matrix. And this happens a lot. because often you have, for example, functions, external functions, which take a matrix, and then the measurements need to be in the rows, and the observations need, or the individuals need to be in the column. And the problem is your data is just the other way around. So for this, and this is a very common problem, that your matrix is kind of flipped upside down, right, or flipped the other way, you can use the transpose function. So what the transpose function does, it takes the first column and makes it the first row. It takes the second column and makes it the second row, and it takes the third column and makes it the third row. So it flips rows and columns around, and that's what the T function is for. I just wanted to introduce to you because we're going to deal with it during the assignments. But it's a really useful function because it happens a lot that your data is just the flipped version of what you think it should be, or what the external function that you're using expects it to be. Right? If we want to use, for example, principal component analysis, then the PCA function that we use expects the rows to be individuals and expects the columns to be the different observations that you did on the individuals. And often your data is just flipped the other way. So transposing, taking row number 1, making it into column 1, taking row number 2, column number 2, and so it's just flipping it. All right, a little bit of a word about variables because this will come back. So in my mind, because I always think about code, not so much as code, but in my mind I have like a physical picture on how things look. And this is different for different people, right? So in my mind, if I think about a variable, then a variable is in my mind a box, like a black box, right? So I can put something in the box, and then I can use the box without knowing what is in it, right? So, for example, I always say that variables are like boxes, control structures are like conveyor belts, and functions are like factories. Because in my mind, that's just the visualization that I have with it. It might not be a useful visualization for you, but in my mind, variables are just boxes where you can put stuff in. Right, so and we have already seen a lot of them. So we can name a variable anything. We can come up with the name. So make sure that you select meaningful names. So here I'm defining a variable called variables, and I put the value 1.5 in. Here I'm defining a variable which is called can, and I'm putting 2 logical values in there. So a vector with 2 logical values. So variables can have many names, and you are responsible for selecting correct names for them. So that's a difficult task, but that's something that we will grow into. And you can put things in boxes using this arrow thingy, right? Or you can use the is symbol. So is also assigns into a variable. So these two things are equivalent. If I say mm5, this is equivalent to nn is 5, right? And you can select which one of the two you want. So, and generally I like to use the pointy arrow thingy. And why do I like the pointy arrow thingy? Because I can flip it around, right? I can say 5, put 5 into, put 5 into 00, right? So I can assign the other way around. While the is always assigns to the beginning, right? So here I'm putting 5 into nn. But using the arrow, I can assign 5 to or I can assign 5 to 00 the other way around. And this is just one of these quirks in R, and sometimes it's useful, sometimes it's not, but I always try to use the arrow. All right, so very good. So for the assignments, because we're almost done, I want you guys on your hard drive to make a new directory, and the new directory will hold one script for every assignment, right? So every week, create a new file. So my file is called assignment1 or answers1.r. And then for the second round of assignments, we have answers2.r. So name the files in a logical way. Don't call them A1, A2, A3, A4, right? You can, it's not wrong, but just be diligent, right? Programming is like working in a lab. What's a directory? A file? No, a directory is one of these yellow folders thingies in Windows. Let me see. I don't have a. Um, so if you go into Windows and you click somewhere and you can say new, and then you have the option to do a folder or a text document or something like that. Yeah, a folder. Yeah. So just create somewhere on your hard drive, create a folder and or a directory. That's the official name, I think. And just put everything into one, right? So then you can also at the beginning of your script use set working directory, right? Because you have to move from where you started R to the folder where you have your answers, and that's not important for the first assignments because we're not going to load anything from disk or write anything to disk. But once we start getting into the later assignments, then you will also have files that you need to load, right? And then you need to put those files into a data folder, and then hey, you get a more complex structure. So when you program, and let me show you Notepad++, always add a header, a comment section at the beginning of the file. So all of my files start more or less like this, where I have a hashtag, and then that is Windows far away. So I always have like a hashtag, another hashtag, and then I have the description of the file. So what does it do, right? So in this case, it would be answers to assignment 1, right? And then add a copyright statement because you are making it. It is your code, and this is important, and it's yours, right? So and so claim ownership of what you are doing. Generally, I have the name of the file, the date, the purpose of the file, and then a copyright statement, and use a lot of comments. So when I think that one of the first assignments is to do something like 4 plus 5, like this, 4 plus 5, right? Of course, you don't have to write a comment here. Everyone knows what's happening. But when stuff starts becoming more complex, explain what you do. And generally what I do is the answer I write down like this. So 4 plus 5, answer is 9. Right? And then we have the next one, which can be sec 1 to 10. Well, that's not a good one. Sec 1 to 10 by 2, and then do the sum of this, right? And then this is my code. I go to R, I copy in the code into R, like this, right? And then it says 25. That is my answer. So I go back to Notepad, and then I write down hashtag answer 25. Not 225. Right? So just to keep things structured. And in the beginning, this seems like a lot of extra work. It is a lot of extra work in the beginning, but in the end, it will really, really benefit you. One of the reasons is why do I do this? And why do I hammer so much on it that I want you guys to do it as well? Is because in the end, it makes your code searchable. Right? Windows can easily search into text files. So this is, for example, something I wrote like a couple of years ago in 2015. So the purpose of this file is the analysis of Hardy-Weinberg equilibrium. Right? It is copyrighted 2015 by the HU Berlin because I work for the HU. So all of the code that I write during the time that I'm sitting here behind my desk is not mine. It's from the university. Right? It is written by me. And then I generally add when it was first written and when it was last modified. And this is not so much for me, but this is for the person that's going to eventually replace me. Because you are writing code, but you're not living in a void. Like you are standing on the shoulder of giants. So you have to know who these people were. You need to know when they touched the file last, right? When the first version of it was written. All of my scripts start with a kind of set working directory, right? So I always say at the beginning of my script, I want to move to the D drive, into the R course, into the assignments. So this is where I store all of my answers to the assignments. So this is kind of an example, but be diligent about it because this will save you in the end. So use a good text editor. If you are on Windows, I always advise people to use Notepad++. It is a beautiful editor. I love it a lot. It has automatic code highlighting, which I like a lot, right? So if I use like sec and sum, it recognizes that these are built-in function in R, and I get this little purplish glow, right? It knows that these are numbers, so they get to be orange. It knows that this is a comment, so it makes it green. So I can directly visually see what's happening in the file. And use an editor which has bracket testing. This means that when I put my cursor behind a bracket, it highlights the corresponding one, right? So here I'm highlighting the last one and it belongs to this one. Here I can put it here, right? And I can see, okay, so this bracket here, which I'm closing here, was opened here, right? And if I go one further, it see, okay, so this one I opened, this one I closed, it opened here. And this is really important because when you start building up bigger and bigger scripts, let me see if I can find an example of something like this, where I am using like a massive amount of brackets, just to confuse the hell out of everyone. Let me see if I can find a good example. Let's do an example in R. So something goat-ish, for example, sequencing. Then no, that's not a good example. Like here, right here. So now I can put my cursor here and I can see, oh, the curly bracket that I opened here gets closed all the way over here, right? You can directly physically see, and this is very important. Had the same thing for something like this. Oh, I know that the bracket, because in the end, a missing bracket will cause a lot of headache. It will be a lot of debugging, finding exactly where it is, and then just being able to put. So if I would have an additional bracket right here, then now it will open it here, and now when I can scroll through the file and I can see that this bracket is actually closing it here, right? So now when I go to the first one here, then now it doesn't highlight it, meaning that this one is not closed. Right, so this one here is closed because it closes here after the paste, but this one is close or is opening and then closing the last one here, but the one here in the front now has no partner. So I know now that I'm missing a closing bracket somewhere, and this is really important. So yeah, if you use Windows, use Notepad++. If you are using Mac OS X, use BBEdit, which is a free editor for Mac. And if you're using Linux, you can use whatever you want. I'm super confused with these programs. Are we seeing R right now or Notepad? Okay, so this is Notepad++, and this is R. So R is always everything in red, at least in my version, right? And it has this R console here, right? And it has the stop button here to stop computation. And perhaps it would be better if for Notepad I would just add my directory browser, like this. But it really depends. So, and in the end, you can use any editor that you want. Is Atom good for R? Yeah, Atom is a pretty fine editor as well. In the end, like, you can use anything. You can't use Microsoft Word, of course. I definitely would advise you against using Notepad. But Notepad++ is a really good editor for code. So, yeah, Jolie-san, this is just something that is confusing at first, but once you installed both of them, then you can easily kind of see the difference. But in R, and that's why we looked at the look and feel of R. Also, R can look very different from time to time, right? Because this is R, but this is R as well. So here, Let's open up the command window. So this is R as well, right? I can just type in 5 plus 5, or 5 to 5, 5 plus 5, 5 plus 5, like this. And then it will tell me 10. Right, so the thing to remember, if you see this larger than symbol, then this is an input line in R. If you see something like 1, then this is an output line in R. So this is an automatically indexed vector. This vector is of length 1. It contains 1 value. So it is something that you just have to kind of get used to, and it can be different for all of the I think I have no, don't worry, don't worry. That's why we're here for, right? That's just to help you kind of get familiar with all of the things. And like in the end, every beginning is really hard, especially when you have no programming experience. And for me, I also sometimes gloss over these things too quickly. I've been programming since I was 4 years old, so a lot of these things for me are very, very logical, and I for me it's really hard to think like a beginner. So if you're saying that, no, can you explain it, then I will gladly take the time to explain it, even if we're sitting here until 6, right? That's why we have a 4-hour lecture, just to make sure that you guys come away with a new skill, right? I can already program, so for me it's not, for me it's really hard to think back, like, what did I not know when I was a beginner? But yeah, so don't feel any burden to ask these kinds of questions. I'm more than willing to explain. And next time when we meet in person, I will send around an email about that, about when we are going to do the assignments together. I put them on Moodle, so do start already. Just download the assignments from Moodle and start doing the assignments one by one. If you get stuck, either send me an email or wait until we can sit together on probably Thursday next week. And then we will sit together for 2 hours, and we will definitely go through all of these things. But will we know if the next lecture is actually in real life at Invalidestrasse? Yeah, that's still not entirely clear. I'm very confused by the corona thing from the HU. Because we have these emails with these Dienstanweisung, right? And the big issue was that we have Dienstanweisung 9, and then we had Dienstanweisung 10, and 9 was wearing mask, and I have to check you guys if you're vaccinated, and I have to make sure that if one of you gets COVID, that I inform everyone. And then at a certain point, they switched to 10, but 10 was not approved by the Personalraad or Personalabteilung, so that invalidated 10, so we're back to 9, and it's completely unclear, at least for me. I have no idea what I should do to have you guys in the building and have you formally in the building, especially since I'm a little bit scared about it, because we have 2 people in the building working in the lab who have immune diseases. So they are either on immune suppressants or they are naturally immune compromised. So I don't want to risk them getting sick, because for them it's a much bigger deal than for me. For me it would probably just be like a short flu or anything, but that's the thing. But I will inform you guys speedily once I figured out how we can do this. All right, let me finish up the presentation. We still have like 2 slides left. Rolando Riviera, I have a question, but I think it would be easy if I ask it orally. Sure, hang around in the Zoom. After the lecture, we can just chat about it very quickly. All right, so use a good text editor. So on Windows, I always advise Notepad++. If you want to use Atom or you want to use Visual Studio Code or another kind of code editor, no worries. We can just do that. And you can use it as long as you feel familiar with it, right? For me, I work Notepad++, R GUI. Other people use RStudio. RStudio has a built-in editor. Other people like to use Atom and run R via the command line. But for a good editor, most important, code highlighting and bracket testing, because that is going to save your ass multiple times over the coming weeks. All right, so remember, clean code is smart code. Here we see the same thing written down in 2 different ways, right? One of them is just not adhering to indentation at all, because it's an unordered list with a list item. So this, although it takes more space, it is nice and clean, right? You can see the structure of the code. So this one is within this one, and the same thing holds for R, right? If we go back to Notepad, then you see also that I take the time to lay out my code, right? So when I do a while, then this is within the while loop, right? So because the bracket starts here and ends here, right? So indentation is very important. Don't squeeze everything on one line. Often you are allowed to and you can, but you should not do that, right? So make sure that things are structured in a way that just physically or looks good, right? So if you look at code and it looks clean, then it's much easier to reason about what is happening and how it works. And that's it for today. So are there any questions? And wait, there's one more slide. So the assignments are available on Moodle. You can get them from here as well if you're just hanging out on YouTube and thinking, oh, I want to learn a little bit of R. So the assignments you can get from here. So R 2022. Those are the new assignments. The lectures are in R lectures. Make sure to add the slash to the end. I wrote my own web server. You should never do that. You should use a standard web server, but I wrote my own and I'm using it and I'm sticking with it. But you need to add the slash at the end. So R 2022 without the slash is a different page, is a page not found. With the slash, it will show you an overview. Let me show you guys how it looks, just because we can do that. So let me go to Firefox. Let me get the Firefox here. So if we go to dennyarends.nl, right, then this is my homepage. And then if we go to R 2022, right, without the slash, it says restricted. You're not allowed to do this. If you add the slash to the end, then you get to my homepage and there's the first assignment. So this is the first assignment. Right, so the first thing is install R, then install the good text editor, create a directory, a folder on your hard drive, create a directory in this folder called assignments1, which is a little bit overkill, but you don't really have to do that. Create a file called answers. So, but make sure that you have a structure that you are comfortable with working in. Again, the example, and then just typing in these. So, all right, very good. Let me see, I had a couple of words of wisdom. The only way to learn coding, to learn programming, is to sit down and code, to do it. You can listen to me for 40 plus hours, but if you don't do the assignments, you're not going to learn. Because I can talk to you guys and I can explain to you all kinds of things. In the end, only by doing the assignments and programming for yourself, like taking your own data that you have and applying the knowledge that you have to this, do you learn how to code. So do the assignments. If you get stuck, send me an email and do it quickly, right? If you get stuck and you're stuck with something for 30 minutes, then just send me an email. I'm generally very quick at responding to emails when I'm not on holiday. So that's the way that it works. And as a word of wisdom, this is not high school. So I won't be checking if you did the assignment. In the end, it is up to you to master a new skill. I can only do so much. I can tell you how things work. I can give you assignments so that you can practice how things work. But if you don't do them, then you won't learn how to code. And of course, clean code. That's good code. All right. So for me, that's everything. If there's any questions, you can ask them now. And Rolando had a question as well. So I will quit the stream. So I will see you guys next week. And I will send around an email informing you how we are going to do this. Because I do think it would be fun to have you guys here do the assignments together, and then I will do the stream and we will have a beamer so you can see me on the beamer or something like that. Um, are we discussing the assignments next week? No, probably the week after, because the way that I'm currently thinking about it is that before we do lecture number 2, we do assignments number 1 together. So then we will be discussing them in person. So I will show you my answers. So hey, you will sit there, you will do the assignments, and then we will take 10-15 minutes and quickly go through them. But I'm not sure how that's going to work yet. So it's a little bit awkward since it's kind of a half digital, half in person kind of semester thing. So for me, I think it would be good if you guys get to sit together to do the assignments. But we'll still have to figure out a way. All right, Anya, a more general question. What is the difference between Python and R? Brackets. Both of them are programming language. It's just that the syntax is different. So in R, when you write a block of code, you use the curly brackets. We haven't touched the curly brackets at all yet. But in Python, you don't use curly brackets. And in R, you use curly brackets to denote. Python is a different language. It has a slightly different structure. But it's a perfectly valid language to learn as well. So, more general question, is there a difference between Python and R? Yes and no, because no, they are both programming languages. They're both Turing complete, meaning that you can do the same thing in both languages. You will just have to tell the computer in a slightly different way what to do. One of the things that R has that Python does not have is the built-in understanding of statistics. Python has no factor type. It does not understand that groups are groups, statistically speaking, right? Because in statistics, you analyze differences between groups different from numerical differences. So there is a fundamental difference in how these languages think about statistics. But in theory, anything you can do in R, you can also do in Python. And anything you can do in Python, you can also do in R, because both of them are Turing complete languages. So yeah, but yeah, we can have a whole discussion about which one is better. I don't think that any of them is better. They're just different. My favorite programming language is actually not R. I have most experience programming in R. My favorite language at the moment is actually the D programming language. So you can look that up on Google if you Google Daylang, or you just Google my name with Daylang. Well, my forum posts come up as well. And it's a language which is very similar to C or C++, but it has some niceties that I really like, which are not in R. It has some very serious drawbacks as well, like it also isn't a language for statistics. But yeah, but there's different languages. Every language has an advantage, has a disadvantage. All right. Any more questions? I'm still here, so we still have 37 minutes of questions if you guys want. So I'm just glad that we got through all of it. Because it's a long lecture, the first one. I know this because I always try to push in the history to make you guys understand it. Rolando, I can't hear you, unfortunately, because I muted Zoom so that otherwise you would be on YouTube asking your question. Why is R called R? Because it's the successor to S, which is a programming language as well. So the S language is the language before R, and R is an implementation of S. That's the correct answer. So yeah, no, there's a programming language called S. It's not really a programming language. It's more of a way of thinking about code. So you have S3 and S4 objects, and R is the implementation of S. It's like the language that I like most, D, right? That is the successor to C. He didn't see that one coming. No, no one sees that one coming. That's disappointing. Why? What kind of like it was invented by a pirate? Like that's why it's called R. No, it's not like that. So no, it's the successor to S. Like D is the successor to C, and C++ is also the successor to C, right? It's C, but then better, so plus plus. People have weird names when it comes to programming languages. There's a whole bunch of esoteric languages out there as well, which are programming languages that you do for fun. Things like a programming language called Pete, based on paintings by Piet Mondriaan. Very interesting language, very fun to program in, but not very useful because you you use paint um, to make your programs. So the programs are pictures, and these pictures they are abstract paintings. So every shape means is a kind of instruction for the compiler. So yeah, if you're interested in programming languages and how these things relate to each other and stuff, then definitely go to Wikipedia and search for the esoteric languages because those are really really fun. There's also a LOL talk language, so that's all based on LOL talk. So, but that's the way that it is. So good. Any more questions? I'm happy to talk to you guys about anything. And if that's not the case, I have to wait 30 seconds, right, on YouTube, at least, so that I know that there's no questions. I could just ask people if you have no questions and write no questions in chat. That C++ is C on steroids. C++ is actually C. Because when you write C++, you're also writing C, right? Because C is valid C++. So a C program is also a C++ program. A C++ program is not a C program. So it's the one is a superset of the other, which means that C++ inherits a lot of the baggage of C. Uh, but every language has its own advantages and own disadvantages. Good. Then thanks, guys, for being here, staying until the end. Pizza for dinner. I don't know. I don't know. I have to ask my moderator if we have pizza, but might be. Might be. Normally, Donnerstag is pizza tag, so that's kind of the rule in my house. All right. Good. If there's no more questions, then again, thanks so much for being here. Like the course wouldn't be fun without you guys. Thank you for asking questions and not being ashamed of asking questions, which you should never be. I will let you know how we will do it next week and how it will work. I'm definitely going to record it because with the whole COVID thing, if people have to stay home or do isolation or whatever, then I think this is one of the ways that people can just continue following the course. And with that, thanks so much, and I will see you guys next week for sure. So, I don't have a button for that. I'm going to my finished screen. So, pizza tag. Yeah. Thanks. Yeah, no, thank you guys for being there. Without you, it would not be as fun. Good. All right, then. See you on the flip side, or at least next week.